of the International on the German, Indonesian, and attacks projects. Before starting, I would like to kindly remind you that eating and drinking are prohibited in this room, except for drinking water and candies that are provided on your table. Good morning, ladies and gentlemen. I kindly ask you to take your seats and prepare for the opening remarks. Good morning, ladies and gentlemen. We welcome you to the second day of the International Conference on German, Indonesian, and attacks projects. Let us begin today's session. It's my honor to welcome you all to the second day of the conference. Today, we will continue our insightful discussions of the future of Indonesian textile sector and its role in sustainability, energy transformation, and CSR. We have an exciting agenda ahead. To officially open today's session, I would like to invite Ibu Yanti, PhD, Vice Rector of Atmajaya Catholic University of Indonesia, to deliver the welcome speech. Please give her a warm of applause.
Good morning. Welcome to Atmajaya. We are glad to see you here. Today is the second day of the INETEX conference that is bridging academia and practice from several industries. Thank you for your presence in this event. We welcome you, Dr. Roland Kehl from DRL, German Ministry of Research and Education, Dr. Bernhard Wayne as the Director of IGES, German, Dr. Fauzan Adziman from the Ministry of Higher Education, Science and Technology, Republic of Indonesia, also Ms. Anissa Fitria from the German Embassy. Last but not least, welcome to all participants. This INETEX project is a joint consortium program between Indonesia and Germany. In 2022, we also had run successfully this program at Atmajaya Catholic University. So glad this program has still continued to present, and yes, finally we still meet here. Through the INETEX program, we expect to establish the excellent networking among academia and practice from textile industry through applied and advanced research outcome in order to support the fifth industrial revolution globally, in particular in Indonesia too. Hope this conference could give you a fruitful result and success for all of us. We thank you for all your kind attention.
Thank you, Ibu Yanti, for the speech. Next, we are pleased to have Professor Dr. Monica Eigenstetter from Hochschule Niederrhein AUG to provide an overview on the projects and conference outline. Please welcome her to the stage. Oh, it's Bernhard. Please welcome Bernhard Van.
Well, that was a little misunderstanding. But if such small things happen in the morning, then everything will go fine today. So I try to get started. Then I also welcome you all. I'm really happy to welcome you to the second day, which is the scientific day today. We have quite a lot of scientists here, and so I'm really looking forward to it. And I really welcome Mr. Adziman from the Ministry of Higher Education here in Indonesia, and Dr. Kahadi from BRIN Indonesia. It's really an honor to have you here. And thank you also, Ms. Yanti, Vice President of Atmajaya University, for the opening speech. And thank you to all of you to be here and to discuss with us. Also yesterday evening we had some fruitful discussions, and so I'm looking forward to the whole day. What's about the project we are speaking? It's about sustainability, and it's about sustainability in the textile industry. I will give you later a speech to what sustainability means. But our mission statement was that the project Enertex promotes innovative and demand-oriented research collaboration between Germany and Indonesia. So we have two companies from Germany, two companies from Indonesia, two universities, three research institutes from Germany, two universities from Indonesia. So we have doubled all the competences and all the disciplinaries in Indonesia and in Germany. And that's one of the main backgrounds also from the Client 2 project. And for me, it's really fruitful, because then you come really deep in discussion, because you are able to speak if the other guys also knows about biomass, about textile engineering, and so on. So this doubling is really important. And our research topic is climate protection and energy efficiency. Yesterday we heard quite a lot about energy efficiency and we addressed the companies. And so this international partnership is in the end for the companies, yes. But we scientists have quite a lot of methods to look for a deeper knowledge in the different kinds of research we are doing here. So we heard yesterday also something about diet stuff, for example, or about how to measure incineration plants in an easier way. And today we will tell you how we did it. Today it's about how, it's about methods. And also about further collaboration. So if you have some ideas to further collaboration between Indonesia and Germany, please come to us, come to our team, come to our universities, and then we can do so. And our collaboration will always be with companies, because we need the practical approaches to settle our results. That is really important. And so in this project it was really a good thing to work together with policy, politics and science and also economy. Because only if these three dimensions are working together and everybody brings themselves inside the topic, then you have good results which can also used by the companies. So the companies are putting questions, and they are putting you as scientists in question. And then you have to react, and then your science, your research will go deeper. That is a little bit the philosophy behind. And we have quite a lot of institutions, as I said. So it's from German side, ICES, it's my institute, a research institute for renewable energies and material flows. And material flows, I will show you a little bit what does it mean later on. And then the Hochschule Niederrhein, which is a university for mainly textiles in Germany. It's one of the biggest European universities for textile engineering. And then we have IFA Institute, is about life cycle assessment, and life cycle assessment in the sense of how we can evaluate the sustainability. And then in Indonesian side, we have Atmajaya. Atmajaya is responsible for the human-centered approach. So without humans, without employees, we can do nothing. And how does the employees, how we can communicate our results to the employees, and how they can integrate the results in their work. And that is also an own research. In our days, we speak from action research, if we do such research. So action research means really, really being in the companies and try to figure out some new things in the sense of transformation. And then we have also STTD Bandung, which is the textile engineering university here from Indonesia. And they have contributed to all the textile engineering issues. And also they integrated within this project energy issues. So now they start to integrate energy issues in the education, in the issues of the university. So the students learn about energy really early, and then later on they can apply this knowledge in the companies. And therefore I think it's really a fruitful project. And then of course we have our two companies. I again have to say thank you to Mr. Achai and Mr. Jason, to Sritex and to Harapan Punya to contribute and also to open their workers and their management to our project and to help us to get the project running. And it's running now for 4 or 5 years. Quite a lot of time, but we had Corona within, and that was not easy in the beginning. And so also we learned as German partners, if we want to go to Indonesia, we have to go as first there and make contact. And that means not contacts by web conference, that means real contact. Sit together, eat together, speak together, and after that a fruitful collaboration will start. But if you are only in web conferences, it is really hard. At first, trust together and work together, see it together and speak together, and then we can go forward. That is also really important to learn as a scientist. And then it's about Indonesian textile industry. And the question is, perhaps also nowadays now, why these international textile industries are a little bit in trouble. And we have also national and international brands. And so it's a little bit about the demand of the world market about sustainability. And sometimes I have the feeling that the companies here are further than some governments. Because now, yesterday Luc Minto told about US, that US now is a little bit not going the way of sustainability. And we need this way, and the companies are ready to go, but they have also to have the need, the demand from customers to do so. And then the brands will ask for sustainable textiles, and then they can react. And that's really important, and that's about the project. And we are looking in quite a lot of details about consumption of resource, externalization of negative emissions, We look about globalization, international research we are doing, and so quite a lot of things are infecting this Indonesian textile industry. And these trading issues are also taking place in the national policies, like emission trading. In Germany, we have the European Trade System 2 now, starting next year, the 1st of January, and then energy efficiency regulation. And also in Indonesia, as we learned yesterday from the Ministry of Energy, you have quite a lot of new regulations, like your emission trading system, which will be roll out also to other things, not only to coal. And so quite a lot of policy is ongoing. And that policy we have to learn. Policy is also a science, and this science can contribute also to our work. And then, of course, it's human-centered. We have this ESG, we have environmental and social impacts, and this environmental and social impacts of the doing from the companies, we can assess and we can try to improve it step by step together with the people. I know it's a little bit a hard word, but you have the word of intrinsic behavior. There are people who are saying there is no intrinsic behavior, but it's a little bit about have it in mind. And if the workers have in mind that they are working on a sustainable issue, and if they have in mind how to operate an incineration plant because they have to save coal and because that is important, then perhaps they will run it in this way. So we have to look for the people and how we can make the transformation together with the people working there. And that's about the environmental psychology approach in this project. And then, of course, we have the brands, and we have non-compliance, which can lead to loss of legitimation. We have a pressure from the brands to do it more in a sustainable way. And what we are focusing in this project, all overall, we are focusing the textile finishing, because this textile finishing has got the most CO2 impact in the textile industry. And we try to contribute directly to CO2 reduction, like Indonesia also told in the COP29 with their own goals and with their own statements, and we try to contribute directly to these national goals from Indonesia. And so textile industry in Indonesia matters, as the Indonesian here knows well. We have 3,200 companies, we have more than 1 million employees, and we have revenues from tax of 13 billion euros, so it's quite a lot. And the heat and power supply is the most critical one if it comes to greenhouse gases, because 85% from the textile industry's total GHG emission is about lignite. And so we try to do it like that. We try to avoid as first the energy. That means resource efficiency and also energy efficiency. And after that, we are looking, if we have a residual energy demand, we are looking how to replace it. For instance, with photovoltaic, for instance, with bioenergy. And yesterday we discussed about, perhaps I repeat a little bit for the people which are new here, we discussed about that this last step to replace the energy generation, it's the hardest one, because you need quite a lot of money. And therefore we had yesterday Paul Bobapata from GTP Indonesia, and he provides loans for the industry, which are long running with a good rate of interest. And then the industries can get a loan to to get these machines in the long term. And that's really important, and that's also one of the impacts of this project, to bring together this Indonesian institution with the companies. I don't want to go through that, but the main thing is we have a path to 100% renewable energy. But beforehand of this path, we are focusing to the machines, for example, from Brückner, which I doesn't name before, sorry about that, Axel. Brückner is another German company which produces the stenters to dry the textiles. And he is the one who consumes the most energy. But he has also solutions, as he will tell you later, that his machines needs less energy. And that's about energy efficiency in the production chain. And that's the first thing you have to do. And after that, the residual energy you can replace. That you have to have in mind. We make a systemic integration and interlinkages. That I told you before about the human-centered approach we have in science here. I think Monica and Aslan will tell also about that later on, about that approaches. And we also have to think we have international level, international value chains, and we have the level of company. And how to find the interlinkages between them, between the demand of brands of international policy and the real doing in the companies. That's about the project. So about capacity building at academic level, therefore we are really happy to have, or some of our partners have a DAAD program running now, out from this project, we can say. It's a DAAD program for textile engineers toward OSH training and so on. You will learn later about it, and ESG. And that is really a good outcome. And we'd like to do also a project like that in terms of energy efficiency, that we have a German-Indonesian cooperation in science about energy efficiency through DAAD. That I will not go through. Of course, everybody of the people here is telling later on his own methods, how he did it, how are the backgrounds, how are the question statements of the research, and how they handle it. Now some expressions for the people which are new here. That are the standards, which Axel Pieper will tell later about it, what it is, and so on. He can do it much more better than me. Oops. And then here are some impressions of the work of ICES. We measured in both industries. We measured the incineration plants and all the heat and heat losses from the incineration plants to the different kinds of machineries. And we used thermal cameras, and we showed that quite a lot of energy is wasted because yeah, they have really old incineration plants, but to replace it means more cost than the whole textile machines would cost. So it's really a little bit a dilemmata. How to replace it, how to be sustainable. They want to be, but how to do it with financial schemes they don't have, or perhaps Bata has, but then they need also a good perspective and so on, and that is not easy. So we developed short-term solutions, which needs nearly no money, but a lot of capacity building. And someone told me, well, we can give you new machines and then everything is fine. But that will be not successful. It's always machines and humans. And you have to tell the humans how to operate with these machines. And you have to tell the humans why they do it, and then perhaps something will be successful. And there are other expressions, I have to hurry up. Here, that's about discussions going on. We have been here quite a lot of time, discussed with the people from the companies, quite a lot of time. And what we are planning to do today, As first, we have some plenaries, and it's methodologies and uptake on energy and innovation project results. And then the second plenary, I come back to the opening words later. The second plenary is about CSR projects, about this human-centered approach. And the third plenary is again, like yesterday, the rollout, but this time a little bit more about rollout in scientific. But as first, of course, we are honored to have two speeches, which are named Academic Pathways for Sustainability, Transformation of Industry. I'm really looking forward what you mean about transformation. And because in Germany we have quite a lot of different definitions about transformation and how to do it. And so I'm really looking forward to know about Indonesian, learn more about the Indonesian approach, and then bridging academy and practice. And that's the main goal of our project. And I hope we did a little bit. And now I'm really looking forward to hear what Prien is saying about it. So, terima kasih, and I wish a good day to everybody.
Thank you, Mrs. Benhard. And now I would like to invite Directorate General of Research and Development, Dr. M. Fauzan Adziman, PhD, Ministry of Higher Education, Science and Technology, Republic of Indonesia, to share insights on academy pathways for the sustainable transformation of the textile industry. Please welcome him to the stage.
We would like to express our gratitude for the invitation, and then first of all, also an apology for the ministry, that the minister is not able to join us this morning. So my name is Fauzan Adziman, Director General of Research and Development from the Ministry of Higher Education, Science and Technology. And then we would like to extend our gratitude for Ibu Yanti, the Vice Rector of Atmajaya University, and then to Dr. Roland Kehl for the discussion as well this morning from DRL, and then the Ministry of Education and Research, Germany, and Dr. Bernhard Wan as well for the warm welcome this morning from the Enatech project, and also Ibu Anissa Fitria from the Embassy of Germany. So this morning I am going to try to bring a topic in terms of sustainable transformations of industry in Indonesia. We will start the discussions by expressing what is the key problem in Indonesia nowadays, and then how we plan to transform through our new ministry. To the next slide, please. So in this slide, you can see that we do have a number of key problems. On the left-hand side, one of which is the productivity of national productivity within the country. And this stems from, first is the ability of our human capital in developing our economic activities, and then through the challenge of this, we bring 4 key strategies. The first one is to improve our human talent in Indonesia, and then the second one is in the context of research and development. So it's very important to be involved in the activities of adding value to our industry, In Indonesia these days, our industries are mainly are not research-based, so it's more or less based on merchant activities, so buying and selling. So this is something that we would like to change, and then through partnerships with Germany and then with foreign countries, including as well activities as what we do today, hopefully this can be improved. And then the third one is we are trying to shift some of our industry from raw materials business to something more on the product development and then industry-led research. And then finally, the way we would like to transform on the decision-making process so that we can develop an adaptive policy within the country. So central to this, to the Indonesia's economy, will be a number of fields that we are building within the country, including food security, creative economy, energy transitions, health, transportations, material and manufacturing, education, smart city, biodiversity, and then on top of that, we would like to build an ecosystem. So this is something that our pathways for sustainable transformations of the industry. Now, if I delve deeper into what is the key in our economic development, there is a mission published by our president and the vice president, and then it is called Asta Cita. So Asta means 8, and then Cita means missions. So there are 8 missions of the president and the vice president. And then within the 8 missions, there are 3 missions relevant to our ministry, which is the Ministry of Higher Education and Science and Technology. So the first being is to enhance the state defense and security system, foster national independence through self-sufficiency in food, energy, water, creative economy, green economy, and blue economy. And then central to this is the mission number 4, which is to strengthen the development of human capital, science, technology, education, health, sports achievement, gender equality, as well as empower women, youth, and people with disabilities. And then number 5 is advanced downstreaming and industrializations to increase domestic added value. So the number 5 is a big undertaking that we hope that through educations, higher educations, research and development, we can be involved in the industrializations based on the added value domestic industry. This is, I think, where it fits in with the theme of the conference of today. To the next slide, please. And then another role of our ministry in the transformations is to be focused on a few key quick win programs that the government is undertaking. And then the first one is to improve the productivity of agricultural through village, regional, and national food banks. And then we also built an integrated top-tier schools within the country. So you can see that the government is very serious to bring up education as a central in the transformation process. And then to the next slide, please. And on top of the mission of the central government and some programs, there are 17 priority programs that we are focusing at the moment. And then out of the 17, there are 6 programs that we are focusing in the context of higher education, science and technology. So the first one is self-sufficiency in food, energy and water. And then number 2, here is number 8, is strengthen education. So education, science, technology, and digitalization is part of a big program within the country. And then number 10 is to strengthen gender equality, protect the rights of women, children, and persons with disabilities. 11, ensure environmental preservation. So this is very important to go alongside self-sufficiency in food, for example, So technologies that we provide should be sufficient enough to ensure that we have preservation of environmental to be thought carefully. And then number 15 is continuing the downstream activities, as we mentioned before. And then 17 is preservations of cultural arts, enhance creative economy, and improve sports achievements. To the next slide, please. And then with that all being said, then the minister set a vision within the ministry itself. So this is our vision. The vision itself is to realize empowered higher education institutions, accountable with good governance, enabling growth and impact. And then we would like as well to enhance R&D capabilities up to the value-added downstreaming, which is industrializations, and then the functioning of science and technology to accelerate sustainable socio-ecological and economy transformations. So the big part of this vision is the last part, that the higher education should be able to help acceleration of sustainable ecology, socio-ecological, and economic transformations. And then now the question is how we would like to do so. To the next slide, please. So here is the paradigm that we are pushing further in terms of the transformations, sustainable transformations of the industry, that the higher educations on the left-hand side should contribute to the right-hand side, to the economic development. So this is a big undertaking, which means we need to break down a few priority programs to bridge the gaps, and a few of activities that we are establishing at the moment is on the growth and strengthening of the scientific culture in R&D. So scientific culture is part of programs that we hope that we can build more and more within the country, and then we open as well from partnership with foreign countries such as from Germany and also from industry, both industry domestically and international alike. And then in terms of economic development, where we are after, first is on the poverty alleviations, and then food self-sufficiency, energy self-sufficiency, targeted subsidies, and commodity downstreaming. So these are a few of the things that we are after in terms of contributions of higher education to the economic. To the next slide, please. Now, the way we try to link up between R&D and those economic development, we are shifting the way we try to fund our research. So for a long time, we are based on the topics or sometimes product in terms of research focus. And this has an upside and downside in itself. The upside is it's relatively simpler because when we create a funding scheme based on topics, there might be some communities already, and then some research fields are accustomed to this way. However, the downside is that the multidisciplinary approach is not well endorsed within the ecosystem. So what we plan to do is we transform this through the paradigm shift that we explained earlier by focusing research on the problems and challenges here. So the reason why we would like to shift our funding scheme through problems and challenges, through problem and challenges, we have two advantages. The first one is we can solve those problems that matter for Indonesia, then problems that matter for our partners. And then second is that will invite a multidisciplinary approach. For example, if the problem is to improve productivity of land, the solutions could be a genomic type of research, but at the same time it could be as well artificial intelligence by analyzing data of IoT, for example, of lands in Indonesia across different islands, for example. So it could start from people with agriculture or biological background or biology background, and then people with the backgrounds of AI or robotics can also solve the problems at the same time. So that will improve the multidisciplinary approach within the country, and also we can at the same time assist in solving problems that are of interest to our neighboring countries. And then by doing this, we would like to encourage global collaborations. So we understand that the key, usually important things to our interaction or partnership with foreign countries are high-value problems. So we are building these high-value problems, and we are inviting everyone to be part of this, and then we are open for suggestions and inputs in developing of these national problems that we would like to solve together. And hopefully by discussion today, if there is any or there are any inputs that we can get of the next steps that you would like us to help solving, we have some funding scheme that we can help in possibly doing so. So in the next slide, we also would like to explain the importance of 2 pillars. So for this sake of simplicity, we introduce 2 pillars within the ministry that we would like to build. The first one is to build the pillars of education, which is the academia part. So this is in the context of R&D and output of papers, publications, world-class journals. And then on the other hand, this is something that we haven't really focused that much, but we hope that to build the second pillar, which is the pillar of application in industry, by building products and then high quality research and innovation that may lead to industry based on knowledge and research. And then the challenge usually then to marry the two. So between the higher quality publications and then product development, there will be some knowledge diffusions, or we call it infusions. So the infusion process is something that we would like to push further, and this is, I think, aligned with today's activities within this room. And then the last slide, next please. And then to close the loop of the discussions on the academic pathway for sustainable transformations of the industry is to provide end-to-end solutions to our R&D by providing an integrated R&D ecosystem within the country to nurture university-based innovation. So we start some of our funding scheme for basic research. So this is mainly through our government funding. And then we shift towards funding scheme, possibly for startups or spin-outs from universities. So this will assist development of 2 things. One is the human capital or talents for university spin-outs or startups to develop further their technologies down the line to business, to the market. And also we do have matching fund with industries where we encourage industrial relationship with universities. And then nevertheless that we won't be able to be fully involved or fully control what happens beyond industrial relationship with universities. So we would like to build more and more partnership. And this partnership not only within the country, and also partnership through different countries. And especially this morning we just had a discussions potentially to have a co-funding scheme with Germany. We have a number of co-funding scheme that we built with different countries over the world. With the co-funding scheme, essentially what we try to do, we put some investment through the relationship, through a co-investment with foreign countries, and then we expand this through partnership that hopefully not only through university and university relationship, but also through university, industry, and government relationship. So hopefully the university, government, industry partnership is the opening doors for academic pathway for sustainable transformations of the industry, and then we would like this to continue in the future. Thank you very much, and then very much welcome the invitation again, and then hopefully we can support further the activity in the future. Thank you.
Thank you, Dr. Fauzan. Please remain on the stage for the token of appreciation and photo session for our documentation. And this token will be given by Roland Kyle. Please welcome Roland Kyle to the stage to present the token of appreciation. And now we'll listen to keynote session, Bridging Academia and Practice by Dr. Cahyadi, Kepala Pusat Riset Konservasi dan Konservasi Energi, and please welcome him to the stage.
Okay. Good morning, distinguished and also the distinguished hosts and colleagues, and also all the participants in ENATEX conference. This morning I represent Professor Chuk. Unfortunately, he has another meeting with our management, so I try to present about our experience in our research center. My name is Cahyadi. I'm the head of the research center of energy conversion and conservation in BRID. Next. This is actually our research center is under energy and manufacture research organization under Professor Chuk. Next. Yeah, if we refer to the net zero emission roadmap, in Indonesia, we can see that energy efficiency become one of the important program, around 34%, in energy sector depends on the energy efficiency, and one of the program in energy efficiency is implement the energy management system in the industry. So we introduce the energy audit program and to support the energy management in industry and also in the building sector. Next. Actually, the most important thing for the net zero emission program is we need to change our mindset from fossil fuel to the renewable energy. So we need to increase our awareness in the environment and also in education, regulation, and also for the innovation and technology for the efficiency energy and also renewable energy. And I think the collaboration with Internasional is required. Next. For the net zero emission, I think we need to focus on future power system, because in the what's called the renewable energy, the scope, the mindset is different with the fossil fuel. Actually, for the fossil fuel, will be based on the centralization, and the renewable energy will be decentralization. So that's why we need to develop technology that support the decentralization system. Next. This is our research area in our research center. Actually, to support the roadmap for net zero emission from the energy system and also the low emission, and then thermodynamic system, electricity, and then the energy conservation technology. Next. For the net zero emission, energy review is as a starting point to look at what's called the energy consumption in one industry. So we can look at the energy audit, and we can provide recommendation for the efficiency energy measure and develop action plan for net zero emission program. So energy efficiency is one way, that low cost way to contribute to the net zero emission program. And then we look at the renewable energy potential in one industry. Next. This is our research group in our research center in Brain. So we can collaborate with there are many research groups that focus on the smart grid system, also waste to energy, wind turbine, geothermal power plant, and then hydrogen, and also the electric vehicle charging station. Next. This is our strategy to develop our technology. We need to measure our program, yeah, based on the technical readiness level, yeah. So we developed from the conceptual design. This is one of case study, yeah, in binary cycle. We develop from conceptual, and then we develop in the lab scale, and finally we increase our capacity to the full scale. Yeah. For the binary cycle, yeah, 500 kilowatt in Lahindong, actually we collaborate with BMBF, yeah, Germany, and now the plan already hand over to Brin, yeah, and this plan is already generate, yeah, electricity to the PLN grid, yeah, in Lahindong, yeah. Next. Yeah, this is one of our research area in electric vehicle charging station. Yeah, because we need to develop charging system technology that can be easily, yeah, to charge the electric vehicle, yeah, two wheel and also the four wheel. Yeah. Next. Yeah, this is waste heat utilization technology that we utilize organic Rankine cycle. Yeah, the capacity around 100 kilowatt electric. Yeah, in Soreang, Bandung. We take the waste heat from the municipal waste, yeah, incinerator, yeah, in Bandung, yeah. So we can generate electricity, yeah, from this waste heat, yeah. Next. Yeah, this is the our research, yeah, waste to energy, yeah, plastic to oil, yeah, and also floating PV, yeah, we increase our local content, yeah, in this technology, yeah. Next. Yeah, this is one of our research group, yeah, in geothermal, yeah, in condensing system and also in the binary cycle system, yeah. Yeah, next, yeah. Yeah, this is our lesson learned, yeah. In Kamojang, we developed 3 megawatts, yeah, in Kamojang, yeah, near the Pertamina geothermal, yeah, in Kamojang, and our local content around 63%, yeah. Our turbine is developed with turbine also generator, yeah, developed with local industry, yeah. So we can produce, yeah, electricity, yeah, around 2 megawatt, yeah, and already connected to the PLN grid in Kamojang, yeah. And actually this research already finished, yeah. So but the plan is still in the location, yeah, and we already make some paper, yeah, for our lesson learned, yeah, in Kamojang, yeah. Next. This is the smart grid system, yeah. We have 100 kilowatt peak, yeah, in our building in Serpong, and connected with smart grid, yeah. Smart grid is very important for develop the renewable system, yeah, because the smart grid, yeah, control, yeah, all the renewable system like PV and other renewable energy, and to make the power quality is acceptable, yeah, and also can be synchronized with the PLN grid. Yeah, it's very important. Yeah. Next. This is one of our research, yeah, to develop the what's called low cost energy monitoring system for the building, yeah, also for the significant energy use, yeah. Actually, in the textile industry, is required, yeah, to monitor the performance, yeah, of the significant energy use in industry like a boiler or other equipment, yeah, that need to be monitored, yeah, to make sure that the energy efficiency measure can be implemented. Yeah. Next. Yeah, this is our activity in energy conservation. Yeah, develop the energy management and also energy audit. Yeah, and then develop a technology for energy efficiency measure. Yeah. Next. Yeah. Next. Yeah, this is our strategy, yeah, to develop the net zero emission program in one industry. So the first we conduct energy review, yeah, in one industry, yeah. We conduct the energy audit, yeah, and then give what's called energy saving analysis, yeah, for and analyze the significant energy use in each of industry, yeah, and observe, yeah, the renewable energy potential in industry. So we can develop energy efficiency measure and also renewable energy in one industry, yeah. So the strategy is depends on the potential of renewable energy or waste heat in industry. Yeah. Next. Yeah, this is one study case. Yeah, our partner. Yeah, in floating coal terminal in Kalimantan. Yeah. How to increase the renewable energy portion. So the first we do the energy audit. We know the significant energy use of this facility. Yeah, so we can make a strategy how to what's called improve. Yeah, improve the renewable energy portion. Yeah, in coal terminal, and also how to utilize available waste heat in this facility. Yeah. Next. Yeah, this is our what's called pilot plant. Yeah, in Serpong. Yeah. So we have what's called in Puspitek. Yeah, in Serpong we develop a smart grid, yeah, in our system, yeah, and also renewable energy, and develop the waste to energy. So hopefully in our research center, yeah, in Serpong, yeah, can implement this renewable energy program in our facility in Serpong. Next. Yeah, I think as a conclusion is efficiency energy and renewable energy is very important, yeah, especially for support the roadmap of net zero emission in Indonesia, yeah. So BRIN develop prototype, yeah, and also intellectual property right, licensing, technology that improve the energy efficiency, also improve the renewable energy, and then try to change the mindset to the renewable energy, develop the technology based on the renewable energy, and also collaborate with other international bodies, and then the most important thing, we support the industry ecosystem in industry that can improve the local content in develop this technology. Next. Yeah. I think that's all. Thank you very much for your time. Thank you.
Thank you, Dr. Cahyadi. To Dr. Cahyadi, please remain on stage for the token of appreciation and token and photo session for our documentation. And for the token of appreciation will be given by Roland Kyle. So please welcome Roland Kyle to stage to present the token of appreciation. Once again, thank you for Dr. Cahyadi and Mr. Roland Kyle. Ladies and gentlemen, we will now begin our first plenary session of the day, titled Methodologies of Uptake on Energy and Innovation Project Results. This plenary will consist of 6 sessions. The first one will be Keynote Academic Outreach by Evelyn Lempa, Hochschule Niederrhein, FTB. And the second one will be Methodology of Energy Efficiency, Performance in Textile Thermal Processes by Mikhail Pozek, IZES GmbH, and Dr. Muhammad Ikhwan, Polytechnic STTT Bandung. The third one will be Motivation and Challenges for the Enatex Projects, Evaluations of Innovation in Textile Finishing by Evelyn Lempa, Hochschule Niederrhein, FTB. Dr. Muhammad Widodo, Polytechnic STTT Bandung. The fourth one will be Energy Saving Potential in the Textile Value Chain by Axel Pipia, CTO Bruckner Textile Machines. The fifth one will be Methodology of Efficient PV Concepts for Power in Textile Industry by Jayanta Jayamana, Sun Farming GmbH. And the last one will be Methodology of Efficient Residual Biomass and Waste to Energy for Co-Generation by Bernhard Wen, IZES GmbH. And then we continue by panel discussion on follow-up for universities, study causes, research activities, intersectoral with industrial cooperation. And this session will be hosted by Professor Dr. Ida Nuramdani, SSIT, MSc. Without further ado, for Professor Dr. Ida Nuramdani, the stage is yours.
Hello. Good morning, everyone. It's an honor for me to stand here moderating the first panel session in the second days of the Enatex Project conference. So, learning from yesterday conference, it seems like we have like two styles of how to moderate the panel session, like German styles, inviting the speakers one by one, and then we will have together here. But the Indonesian style will invite all the speakers to the stage, and then we will have discussion. So I will take the Indonesian style, so I'm not alone here sitting. Okay, for the first plenary session, we'll have the big topics of methodologies and uptake on energy and innovation project results. Before inviting all the outstanding speakers, I would like to first extend my warm welcome to the distinguished guest, Mr. Roland Kyle from Federal Ministry of Education and Research. It's only my greeting, and then also for Dr. Fauzan from Ristek Dikti, and then Ibu Anissa Fitria from German Embassy, and also Pak Dr. Cahyadi from BRIN. Thank you for giving the keynote speaking this morning. And now, without further ado, I would like to invite all the speakers. Ms. Evelyn Lempa from Hogeschool Nederrijn, Mr. Michael Forzik from IZES, Dr. Muhammad Ikhwan from Polytechnic STTT Bandung, Dr. Muhammad Widodo from Polytechnic STTT Bandung, Mr. Axel Pieper from the City of Bruckner Textile Machines, Mr. Jayanta Jayamana from Sun Farming, GmbH, and Mr. Bernhard Wern from AGS GmbH. Please, welcome. Yes, please. On the chair. On the chair. Okay, thank you for the all outstanding speakers for this session. Please sit down. Well, for the sessions, I would like to invite first all the speakers to present each 15 to 20 minutes, and then we will continue with some discussions. Participations from the audience also welcome, so please get ready with your question or concerns regarding the presentation of each speaker. Thank you. First, I would like to invite to please Evelyn to be to give the keynote academic outreach about the energy on innovation project results. Please.
Thank you, Ida. Thank you for all of you joining us here for this academic outreach. I believe my, perfect, thank you. That's working wonderfully. First of all, good morning to all of you from academia, from industry, from embassy, from all the very many organizations that are joining us for this event here in Jakarta at Atmajaya Catholic University. First of all, before I even start with my presentation, I would like to convey my very warm greetings from Professor Maike Rabe. She's the director of our research institute, for which I am a scientist. She was supposed to do the keynote here today, but unfortunately she's also not available, and asked me to, first of all, convey her warmest regards, but also for you to enjoy whatever I'm going to forward on her behalf today. So the topic is really the motivation and the challenges that we faced academically, scientifically, for or in our Enertex project. Before I want to go into those details, how did we go about, or what is the methodology on the topic? I would like to show you a very small video. Actually, about 5 days before I left for Indonesia, end of last week, I saw a film on television in Germany. That's why there is no sound to it. And it really impressed me so much that I needed to show this here to you today. It shows the Arctic ice sheet, Greenland, and how warm it gets currently. It is 4 to 5 times more temperature increase than anywhere else in the world. And the ice starts melting. It is melting 30 million tons per hour. 30 million tons per hour means around about, if I remember correctly, something like nearly 4 millimeters per year. That doesn't sound a lot, but if the whole ice would melt, the sea level would increase by about 7 meters. Now, I don't need to tell you what that means for us, being here in Indonesia, in Jakarta, pretty close to the sea, but also being anywhere else in the world, pretty close to that. If we hit 7 meters higher sea level. Result would be, next picture please, would be floods like we do know them in Germany or anywhere else in Europe or the world. Next one, please. Pictures like this, that was in 2021 in an area in the middle west of Germany. Was really very serious flooding there. Next, please. But you know these pictures also here in Indonesia. This was, I think, a flood in 2018. Or, next picture, please, a flood here in Jakarta. I think that was 2018, if I researched that correctly. Now, these pictures, and even the little video that I showed you beforehand, is the basis or the motivation for us to run the Enatex project. We need to stop that climate change. We need to do something to stop that global warming. Now, how did we actually go about it? Next, please. We had to change we do have to change the environmental impact of the textile industry. Yesterday, if you had joined us already, we talked a lot about the processes, we talked about the results that we found in our various research topics. But basis is we need to change that impact that the textile industry has. It is a really, really energy-intensive industry. As we already learned yesterday, up to 10% of the global carbon dioxide emission, greenhouse gases, is caused by the textile industry. It is also, on top of that, very, very water-intensive industry. It's actually the second largest consumer globally of fresh water. And it is about 20%, or it's causing about 20% of the global wastewater. I mean, here in Indonesia, textile industry is really large, but there's many other countries where it's not quite that large, and yet we get to these global numbers. So that impact must be reduced. We must find solutions in sustainability, circularity, and energy efficiency. The ways of how we did this, we discussed yesterday. Often these rules, improvements can only be enforced by regulations, of which we also already heard a little bit yesterday. Next, please. So one of the topics that I just mentioned, we can only improve the situation if we think of sustainability, of sustainable processes in our industry. What does sustainability mean? We talked about it so much, but just one of the definitions that I found is meeting the needs of the present in a way that does not limit opportunities of future generations to meet their own needs. For that, in recent years, 17 sustainability development goals have been developed or have been shown. to really look at economical, environmental, and social aspects. We all know these, and that's definitely a base of how to improve the situation in the textile industry. Next, please. Well, we are here today not really to talk about results, but we're talking about bridging research and industry. Thankfully, there's quite a few industry partners here, and in the Anatex project, we had really two wonderful industrial partners where we could try out all our ideas, no matter whether it was on energy efficiency or on innovations or on the ESG topics, etc., etc. So we need that industry, or it is for that industry that we look into innovations. So we have the policy and regulatory support. Now we need to somehow find transfer of goals and maybe do that by incentives. We have very well established in this Anatex project the industry partnership and the technology transfer. We scaled quite some of the ideas from laboratory into industrial implementation. And also more this afternoon, you're going to talk about capacity building and education in the industry. Next, please. I don't even want you to be able to see all these little tiny laws and regulations, but I want to show you what made us think of Anatex. There is many, many rules and regulations in your country, in our country, in Germany, in Europe, globally. And there is so many that we really have to look at what and how can we fulfill such regulations in order to make the textile industry, let's say, better. Next, please. There is the EU strategy for textiles, certainly one of the motivators for our Anatex project, or to write that proposal some 6 years ago. There is quite a number of key actions, 9 are mentioned here, for any products placed on the EU market. So if any of the Indonesian companies, textile companies, want to place their product onto EU market, they will have to fulfill some of these rules and regulations. Certainly one that we in Anatex project from an innovative point of view we're looking at is the eco-design of the product, of which I want to just dwell a little longer now. Next, please. In order to develop an environmental friendly product, we from the start have to look at the design from an economical point of view and from an environmental point of view. So we need to save energy, we need to save carbon dioxide emission in order to stop the global warming. Each and everyone in private can do something about it. Industry certainly needs to focus specifically on that. So what options do we have in textile production to save energy, which is the topic, or which is the E for in the title of our project? We need to first of all select the energy supply. So where is the energy supposed to come from? I think, can you click next one? Yeah, so we need to select which energy supply form do we have? Do we have renewable energies? Do we work with the lignite that you have available at fairly low cost here in Indonesia? We then have to perhaps improve on the energy input. So we have to find solutions. How can we improve whatever we're putting into? Next, please. We can see some of the work that the colleagues are going to present afterwards. We then also can look into machinery. We can select what kind of machines are probably reducing the energy consumption for a certain product, and how can we control it best. Next, please. We can see here a typical example of a stentor. We can also optimize processes, and we can also optimize all the substances and materials used in production. Next, please. So the processes we can optimize, but we can also, next one please, optimize the chemical consumption. And last but not least, we can control and also assess those innovations by specific tools, which again is topic this afternoon. Next, please. Right, this is just to give you a very brief overview of why did we really write a proposal, Enertex project. Why did we want to get the Indonesian textile industrial partners as well as the academic partners? Why did we really write this proposal for them, and how we went about? Next, please. The various colleagues from the various institutes and companies will really focus onto now the real methodologies they will show you. So at first it is Michael and Ikhwan talking about the energy efficiency performance. That's the second part that I just mentioned. So once you have selected your energy form, then you must ensure that it performs well. Thereafter, I will tell you something together with Mohammed on the innovations in the textile finishing. Then Axel is going to talk about the Stenta operations and energy saving potentials. Thereafter, Jayanta is going to talk about the PV concept for power in the textile industry. And finally, Bernard will tell us something about the residual biomass and waste to energy. With this, I'd like to say thank you for listening, and I'm looking forward to seeing all the various methodologies in the different topics of what they achieved for bridging academia and industry. Thank you.
Thank you, Evelyn, for giving such urgent call for us, especially for textile industry, to be aware of the earth situation related to the energy consumption in textile industry. Now, I would like to invite Michael Porzik from IJES and Dr. Muhammad Ikhwan to talk about methodology on energy efficiency performances in textile thermal processes. Yeah. Okay.
Welcome everybody today to our presentation and for energy efficiency in the Indonesian textile industry. And I also thank you very much for being here. And just to say in the beginning, Mr. Mohammed and I, we will share the presentation, so will make half of the time. So I would like to ask the Master of Ceremony, Tanya, to help me with the minutes, that I not take too much time. So it would be very nice that I know how fast I have to be. Okay, what we want to present to you today, just quickly a reference to the challenges. Why is energy efficiency and energy management so important for the companies, also for the academic sector? Then a very short introduction about the methodology we applied in the project. And then Mohammed Ikhwan will take over and talk about the follow-up, the constraints, even implication to the academic sector, especially for the ST Bandung. So let's start very quickly. Textile companies, they have a challenging issue. They are very versatile. They have different steps of production. They are grown, old grown, sometimes family-based, small and medium enterprise. We have a very diverse structure. So energy costs are sometimes, or energy are not so in the focus. Focus is more on production and on quality. So, but energy efficiency, like we talked today, will be in future, as we heard in the morning, all the constraints from outside, a big issue, a big task. to tackle. So there exist opportunities for energy efficiency, but they have to be tackled, they have to be solved, and it has to be known that they are there. So there are limited resources, even in the companies, and even also maybe on the academic sector, but we discussed today about the know-how and information on technologies, practice, and implementation. So these are issues we identified. So as a first follow-up, there could be teaching, training, realizing of process optimization, a very big outcome for the textile industry to optimize the operation. So research and introduction of energy efficient technology must be also part of a new curriculum of universities. And of course, they could also provide training information to the industries to come to the place and held training courses, which is in Germany is very usual, which is also a way of generate income for the universities in Germany. So there are a lot of options we can tackle in discussion also as follow-up. So the main goal of the project was to introduce or to set a goal for the energy management. So energy management needs also a methodology, a standard. The ISO 50001 is the international standard for energy management systems. So it's on the operational level, it's actually on the management level, a process you have to start together. It's for the whole company, all levels of employees have to be involved there. You prepare ideas, you collect energy data, you identify where are my problems, where I can perform, and then you set your own goals. You said, there I want to be better, there I want to increase here the energy share of renewables, etc., etc. You selected for your different production units. You make an economic evaluation. Of course, you can't do everything, you have to make priorities. And then you prioritize and make a kind of timetable, a schedule, when you will do what, and set your objectives in the program. You publish them in the energy policy. You know, this may be from the quality management or energy management, so it's the same structure. You integrate it in your business. So you're really serious on this one. It's a kind of compliance issue to get a goal. You are accountable for this one. So it's a really serious step. And of course, you make documentation, you have to make a data assessment continuously and have internal audits and review. And then you are certified, which is very, very important when it comes to international trade, international demands of brands, or even international policies we heard. So the energy management is an integrated compound to become not even sustainable, but also to fulfill the demands maybe the market has on you in future on sustainability in the energy sector. And as an intended outcome of this methodology, we applied to support in the project is, of course, cost savings. On the long term, you increase the longevity of your machinery because you use them in the way they should be used. You improve maybe investment planning, even accountability for the banks, for financing, and the overall efficiency because you think all components together. So this is just very roughly the idea behind the approach methodology. And within the project, we can't serve the world, we can just start. So we're starting here with the energy process optimization by analyzing the process. And there is a European norm, the 16247 we applied, which gives you a standard how to proceed. That is the methodology we use in the project together with all partners. We had a kickoff meeting. We started to get preliminary data to analyze the current situation. Then we made on-site visit and also get more deeper in data analysis where are gaps. We even did our own measures together with all colleagues and now in the reporting and concluding phase. So, and the result you see on the should be that we identify already measures, where to act and even prioritize them, which is actually the first step in energy management system. So this is now just a very quickly show you how we implemented the methodology. So at first, of course, you make a literature research, you have research on site, you get informed yourself about what kind of system. Here, exemplary, I show you on the combustion system, how we proceed. You have different system grade, fluid size, you have different sizes of installed capacity, different rated, that means designed, full efficiency, and of course, you have a typical investment cost. So our goal was to look on the system exemplary with the methodology, how is the current performance of the system, the efficiency, and where are maybe possibilities to optimize and how maybe to optimize. So Then the next step is you have to understand the system, not just the boiler. You have to understand how it's connected. You see here the different errors with the different in and out flows of, for example, for a steam boiler, you have combustion air, you have exhaust air, you have different echoes, which means you take out the energy from the exhaust gas and heat up steam water or even the combustion air. You have a cyclone, which you take to remove the pollution, the fly ash. And then you have also a scrubber where you wash the exhaust gas to get even more pollution out. And then then it goes up to the chimney. So you have a very complex system and you have to set the balance. You can't maybe not measure everything. So we set the balance on the left side on the boiler, on the input-output flows to get the efficiency of the boiler. So that's how it looked like we transferred this one in the equations for the academic sector, just as an overview. It's pure thermodynamics, so you have always a heat flow, a Q, and it's defined by the mass flow and the specific heat content of this mass, which is mostly defined by the heat capacity of gas, of water, of oil, and of course the temperature you put in and you get out. So there is always a temperature shift. Of course, with a heater you heat up. But with this methodology, you know where are my flows, inside, outside. You even have radiation. We also triggered radiation, or heat radiation convection. So this one you have to measure. You need tools, you need equipment. That's we brought together here in Indonesia and made all the measurements. So what we found very quickly is with this methodology, here you see the different flows, very, very roughly explained, and the red one are the losses we found. So of course we made analysis, chemical analysis of the coal, because when you want to know the heat, you have to know the caloric value. So you make an analysis of each element. Then you can determine. You can even say how much ash is inside and water, because water means you have later to evaporate it and spend energy for evaporation. So you know less water, less energy wasted. Then of course the combustion air, you can see is there is a preheating or not, how much energy you can take out of the exhaust gas to preheat the air. So you can derive from this data, first how accurate they are, and secondly what is possible, where are opportunities for improvement. This was the next step in this methodology of the European nation, of the European Union. So this is just exemplary, then the result, just adapted for typical boiler, steam boiler you can find in Indonesia with a specific installed capacity, operation hours, and fuel efficiency. I showed this yesterday already, so maybe some people will remember. So then you make an analysis. You look where are could be realistically potential for improvement. I told you before, within the energy management, you set goals. You have to identify what you do and how much you can do within this one. So here are different issues you can tackle and for improvement, and you can rate, okay, how realistic is it to get there, where I get the most. So already you can see if the improvement on the bottom of fly ash, which means to remove the carbon by better firing, it seems to be very important and should be taken first. And now out of this one you have to develop measures how to do it. And this is then the next step. You also make an economic application, I said to you. So you can also see here, it's not even a lot of energy, it's also a lot of cost. And of course you have a justification. And you know, okay, when I can save this kind of money, how much I can actually afford to improve. Does it make sense or not? If the invest or the improvement is much more expensive than here, you maybe don't do it. So this is a lot of implications, and you have to know, and you have to do it. So you need really a methodology to go through all these issues. And then the measures, here just to display some very rough measures, what you can do. But all the measures imply also maybe investment in drying technology. You have to install a recovery system, which has to be designed specifically for your combustion system. So these are all the follow-up issues. We not take it in a project specifically, but have to be done in a midterm or even short-term time. So, like I said, it's subject to selection, finally economic assessment of invest and follow-up business cases, and of course then implementation plan. So, and finally, like I showed you, so this is on the left side, the analysis of the current situations methodology of the European standard we applied in, and already can contribute to a start of the overall implementation of energy management systems. So it's always the start you have to do. So it's just a conclusion before I switch to Mohammed. This is be adaptable to all technical systems. We just made it here now for the combustion system, but you can also do it for textile machinery. Everywhere you have energy out and inputs, materials flow, steam comes in, water comes in, hot water, you have thermal oil, and then you have a product, and of course you have waste energy, for example, condensate from steam or less hot thermal oil. So we made with Brückner, with Axel Pieper, such a analysis of the standard. Maybe we'll hear later from Axel about this methodology they applied to rate the efficiency of their standard frame. So this is adaptation actually of the methodology. And of course, it has to be known, to understood. You also don't, it's not just a black box, you have to look into your machinery. If you have a washing machinery, you know that you have different washing steps in the textile factories. Are there heat exchanger between what is with the wastewater? Is the waste heat of the first washing step used for the second one? So you have different implication and during the washing or the scoring, bleaching, how to apply them. So this is everything you have to know. You know it, but also the energy flow must be known in the future to understand maybe where's optimization possibilities. And of course, on the academic scale, you can train and do research at lab scale, because you maybe have a small scale application of a textile machinery which equips sensoric, and then you learn on the small scale how you can implement it and to understand the bigger one. So this is just a roughly conclusion, and now I would like to hand over to Dr. Mohammed for the implication of all the work to SC Bandung. Terima kasih.
Okay, thank you, Michael. Then I will continue my task about. I will explain constraint and application for education sector for our campus during our join the NATEC projects. So before that, STT Bandung is one of the.
There's no screen?
Yeah. Okay, so I will start with our curriculum structure. About we have three majors in the STT Textile Bandung. Then one of this department is related to the energy project in the NATEX. The major is the textile chemistry department. We have 166 credits in this textile chemistry department curriculum, and from this structure curriculum, we have a textile processing subject about 51 credits, and energy and environmental subject related curriculum about 7 credits. So from this curriculum structure, we can see that our curriculum is most focused on the textile processing, and we not yet focus much to energy management, and so we have some obstacle during this project. We need to review our curriculum, so in the future we can improve much to help the industry, textile industry especially, in their energy management. So STT Bandung is from the based on this curriculum structure, so we can say that our expertise is more in the textile production rather than the energy related issue. And our existing teaching module have addressed some energy supply module, but not in detail for the calculation and or practical measurement of the energy management. So mostly our teaching also based on the literature and existing set of data, so not based on the directly measuring the parameter of the energy used in the machineries. So we need to improve this. And why we cannot do this? Because we lack of the instrument. We don't have the instrument to do this. So maybe we hope that in the future we can get some financial support to have this kind of instrument. So we can teach our students and to do this measurement directly in the as practical, particularly in the laboratories or in the field site. And also thank you for the NITEC projects, because this NITEC is the first project that address the issue of energy efficiency and renewable energy in detail. So we learn much within this NITEC projects. As I joined with the energy groups in the NITEC project, we have a training from the ISIS, how to measure the energy parameter in the process, in the like a boiler system, and also in the like in standard machineries. So here, what activities we do before. I would like to compare the activities in STT Bandung before the NITEC projects and during the NITECs, then what we would like to have after the NITEC projects. So in education, we have teach our students to calculate steam boiler efficiency by direct and indirect method, but this is only theoretically based on the pre-known data. So we didn't measure the input and process of each of the energy flow from directly to the machine or the steam generator. So this will be improved if we have the equipment to do this on site. At least we can have instrument that we can use in our laboratory. So also in our laboratories, we don't have any combustion system yet, and so our student cannot learn directly how to measure the energy flow balance to know the efficiency of the energy. So this is one of our big constraints to implement this energy management. Also in the research topic, our students usually they more focus on the textile process optimization rather than energy efficiency. And also our public services also more focused on the provide training on textile processing knowledge. So we need to improve this public service also with the efficiency energy management that now we know that in industry need this to be realized in this business. Okay, this is teaching application for STT Bandung after the NITEC project. So the teaching and training module for textile industry on maintenance of the textile machine in combination with OH module within the collaboration with the Netherlands and also with the company. We need more and detailed training on particular parameter measurement on machineries, and also strengthen our academic curriculum regarding the energy management and efficiency topics. And also for our students, we need to extend the curriculum on the energy management to encourage the research by students by the bachelor thesis or also the master thesis. And also, we need to know how to transfer. We need to our lecturer be trained what necessary know-how for this topic, and also we need some collaboration on cooperation with another institution to improve our capacity building in the energy management and related this energy management topics. Yeah. And yeah, this is also a challenge for implementation of these energy projects, because we lack of equipment for teaching and training in our lab scale. So we need some sensors or flow meters and some equipment for our students to practically use how they measure these parameters. And also research conducted in the STT Bandung, usually they do in the laboratory, but we don't have laboratory related to the equipment that support this energy management measurement. Also, the current practical training, our students, they have current practical training consists of 2 semester training in industry, but mostly this topic, the research topic is mostly in the operation of the textile process. So very rare that our students raise the topic on the energy management system. Okay, maybe this is my last slide. So thank you for your attention, and we hope that from this outcome we can improve our academic curriculum, and also we still need some support, especially for our laboratory and financial support for the equipment, so we can improve our curriculum and improve our student competence regarding the energy-related management. Thank you very much for your attention.
Thank you, Pak Ikhwan. Next, I would like to invite Evelyn and Muhammad to present about motivation and challenges for the INATEX project, evaluation of innovations in textile finishing. Please.
That's the one, yeah?
Share.
Yeah, I can see it. I'll run it from here.
Shall we stop it?
Can you read?
Vermutlich muss man es mehr stoppen und dann wieder freigeben.
Perfect. Yeah, once again, good morning, and thank you for having us here for the part on the innovations in textile finishing. That's certainly a little bit different to what the team mentioned before, but here we also had really a lot of interaction between the 2 universities, but even more so with the 2 companies involved in INATEX projects. Why, how did we have to look at the methodology for this project? The goal or the ideas we placed in the proposal for this project was the reduction of energy consumption and carbon emission by innovation, by innovative technology. There was 2 main topics that we looked for innovations in textile operations. One was the development of minimum application systems for dyeing and for chemicals to be applied in a different way than we usually do this. The second one was really a technology, ultrasound, for the cleaning, for the washing and finishing of textile surfaces. Now, both these technologies, well, they are technologically available, so the technologically readiness level is high, but at least the second one, ultrasound, is not really existing in textile industry at the moment. Minimum application is probably already a bit further advanced, but ultrasound not at all. So we had to think about how can we really find ways to implement that into industry at a later stage. So these were the goals. How did we go about? Similarly to what Michael and Muhammad said before, we had to, first of all, get a status quo in the industry. So we really did lots of screenings of what kind of process routes are the two companies that we're working with in this project, what do they follow? Do they follow continuous processes, for example, pet dry? Do they follow discontinuous processes, totally different, for example, in jets? Or are they doing semi-continuous processing, for example, cold pet batch processing? We had to evaluate all these production steps in textile finishing. What actually do they do? It's very different whether you produce cotton or viscose or polyester or wool or any other fiber available. So we had to evaluate what are they doing. Are they doing singeing in the pretreatment? Do they do desizing, scouring, bleaching, and all these processes? What is common in pretreatment here? Then we checked or evaluated, did they do dyeing? Did they do printing? Did they do digital printing? And with what dye stuffs? On what machinery? And do these companies do functionalizing? Do they give the fabrics at the end, before manufacturing into garments, do they give it a specific function? And if yes, which one? After all that, do they do drying processes? Of course, usually, because we're working in aqueous medium in the textile industry, before manufacturing, at least once the fabric needs to be dried. Often it also needs thermofixing. So all these processes we had to evaluate, are they done here locally or not, and in which sequence? Furthermore, we had to find out what kind of dye stuff systems are available and which ones are used in the country, globally. For cotton and viscose, very common in garment manufacture, or for future garment manufacturing, is reactive dyes, as we discussed already yesterday, but we can also use direct dyes or wet dyes or even a couple of others. For polyester, you are a little bit more limited. Most cases you're using dispersed dyes. We also had to evaluate what kind of finishing chemicals did you use. And finally, what's also really important to look into innovative technologies, what are the customer requirements? So the customers that are finally buying the materials from the industry, what is their requirements? Are they local customers? Are they international customers? Do they have specific fastness expectations? Do we have to fulfill any certificate demands? All of this was status quo for us to consider what kind of innovation can we possibly implement at a later stage. And of course, we also had to look at the status quo in research, because as I mentioned before, definitely ultrasound in textile technology is not really at any TRL. So we had to do a lot of literature research on these innovative technologies that we wanted to implement with the companies in textile finishing, focusing, of course, that's the focus, on energy savings. So we evaluated both these ideas that we had for the project, minimum application and ultrasound. Can we optimize processes with that? What is available yet on literature? Do we understand those mechanisms? I must say, I'm not sure so much about you, Mohammed, but the ultrasound technology in textiles, we really had to understand that mechanism ourselves at first. And we had to, of course, look into, do we really follow the idea of sustainability with those two innovative technologies? And then, of course, during the whole project work, we always had to compare our innovative ideas and proposals with the conventional ones and perhaps with the best practice processes. So that was really to get a status quo in industry and research. Then we had to approach the ideas that we wanted to have. So mostly, really, both of us in these two topics, we went not so very highly scientifically because there was no base available. It was very highly empirical research. We systematically really observed what is available. We measured results that we figured out, and we really experimented a lot. At first, we got real data together with the companies, kind of really quantitative, by the experience of us rather best-aged scientists. We contributed a little bit with our own experience, and we discussed it a lot with other experts in the field. We also developed operational tools of how do we go about it. And really, we developed or we approached the idea of how can we implement this by developing and assessing not really a survey, but rather a data collection of the current status with the industrial partners. Really, at the very, very beginning of Enatex, we were still in the middle of the COVID pandemic. It was difficult to travel here, but yet we had to really meet. We had to meet, but we also had to meet the local companies. Of course, Mohammed knew them. You were there. You have a lot of students here. I never met any of them. So we had to meet online, and we had to get information online. I can only express my extremest gratitude to the two companies that they, for months and months, during this difficult period of time, that they supported us with really trustfully giving us information on their machinery, on the dyes that they're using, the chemicals they're using, the requirements they have, the problems they see, all of this purely online in the first months of the project running time. Eventually, thankfully, we really met in person. We had the feeling we already know each other, but yet we really never met. Finally, we really could go on site, meet the universities, and also together got a very wonderful introduction to the two companies and validated really the information that we gathered online before. We interchanged a lot more additional information and also things that maybe we've forgotten before or that came up newly. And we discussed many challenges and bottlenecks that the companies are facing or were facing at the time. And of course, we exchanged a lot of further information with SDT Bandung locally on site. Well, practical operations. After we've collected all this data and gathered ideas of how can we go about and how can we implement the two new technologies that we wanted to focus on, we did a lot of laboratory work at our labs in Germany on minimum application, rotor spray, as well as kiss roller. In addition, because we don't really have that little machine in our labs, we could use the lab of our partner Brückner, because they have such a unit in their laboratories. We checked on innovative dye-stuff systems in the lab. We also eventually were able to do trials on ultrasound washing. We used always the recipes, even if slightly adapted, of the local companies, and we also used all their materials and only their materials, because that's for us the only way of really being able to introduce that at a later stage. Yeah, and we implemented some of the lab work that was potentially useful to the companies here. We introduced that into production, and STT Bandung kindly really observed those trials and really provided us in Germany with the results and with further problems, etc., etc. But of course, we did face some challenges during operations. The minimum application that we were thinking of in theory when we were writing the proposal is definitely a very substantial, very energy-saving technology. However, the one-sided effect that we were thinking of were not really required by neither of the two companies, because that's not the products they're producing. So we had an idea, but it was not really very clever for the two partners. It's clever, but not for the two partners. So we faced a bit of a problem here, as they don't apply it. Then we also said minimum application must include really sustainable dyes and chemicals. Well, there we had a bit more of facility. So we asked the industrial partners what kind of dyes and chemicals are they using, really very conventional ones, and we did minimum application with really innovative dyes, saving an awful lot of resources for the dyes itself, for the washing off, and for the energy for heating that water. We faced challenges in the ultrasound technology, quite substantial, because there is no such machine. Nowhere, basically nowhere in the world. Towards the end of the project, I had the possibility to visit a company in Turkey that has actually installed one ultrasound machine for washing off. And also towards the end of the project, on the last third, we received a prototype continuous machine to do numerous trials on afterwards, but it was all a bit of a challenge at first. However, we overcame most of the problems, or the challenges, let's say. We found quite some interesting results. So really the innovative dyes that I really presented a lot about yesterday, they are ready for implementation, and they're not only ready, they have been implemented here with the local companies. On ultrasound, completely on minimum application, I would say the data available that are available on research, but also available for us now on in the project, is basically too little. However, the project gave us the possibility to really offer these special, use that special research focus through that project, validate data for the scientific community, generate them, and also publish them in articles accordingly. Maybe to roll it out just to the academic sector, we will use the results from the project as added value for the study course at our university, sustainability in the textile value chain, really that we can achieve energy efficiency through these innovative technologies, including our research findings enriched by the validated data from the project and transfer from the results here from the local workshops. The rollout of these innovative technologies will certainly also include, or did already include, internships in local production entities, but also thesis of bachelor and master students at our university, and as far as I know, also with Muhammad, who will refer on that in a minute. Yeah, we will certainly export German, Indonesian study contents. Well, we'll implement them at our university. They will implement it here at STT Bandung. Some, not so much, because in our textile university will also use those data at Atmajaya Catholic University, and hopefully it will be taken abroad to all other such universities. Well, I've spoken a lot now on our part of the project. But of course, I would like to hand over to Mohammed to give us his insights on the local part of it.
Yes, thank you, Evelyn, for the presentation. I guess I need to tell you that the minimum application is actually, when we talk about the minimum application, is actually the minimum use of water. So it is always obvious for both of us, for the people in the project, that minimum application is the use of machine that will allow us to use little water or just a minimum amount of water. So that's the technology that we are talking about. The minimum application is the use of machineries or technologies that allow us to use the minimum amount of water in the process. And then I guess I just need to make some comments or overview about all those things that Evelyn has explained. Is that we are working thankfully with two industries, with Pak Jason here from Harapan Kurnia and Pak Ajay from Sritex. But then the results from this work that we have need to be expanded to other universities, to other industries, because this is just a pilot. The first findings, but then it gives us a stronghold basis for us to expand that to other industries, because the topic of this project is the energy efficient for textile industry, especially for the dyeing finishing industry. So it doesn't have to be like the precise solution for the specific partners that we have, but then the ideas of using less amount of energy, the strategy will be explored further with the other textile industries as well. And then we also have to understand that the industries in Indonesia is not only cotton, but also polyester cotton. So we need to do some adjustment to what we have already experienced with this project. That's the first. And then the remark that Evelyn has mentioned for the academic rollout of innovation, and then internship, I guess this is important, because then we have our students to bring this technology or innovation throughout the industry. So developing the program for internship, which is supported by the industry or by sponsor, is also important. So what I have in mind is to have to invite sponsors, to invite cooperation that will also not only that will strengthening the internship in the industry. So with this project, I guess we can also have the type of internship that will allow our students to go to the industry in Indonesia, supported by the industries from the Germany, for example, or the experts from Germany or German industries, but also I guess we'll also open up the possibility of sending our students to do the internship, the German industries as well. We did this already with other projects that we sent our students to China, for example, and then also with the other project from Erasmus Plus, we sent our students to several countries in Europe, to Belgium, to Greece, and also to Spain. So we can also expand those type of the program within the scope of these ideas of this program. So that's pretty much the comments that I have, just to add up to what Evelyn has explained. Thank you.
Dankeschön. Thank you. Terima kasih.
Thank you, Evelyn and Mohammed. So we have learned lots about how to minimize the use of water and energy in terms of process. Now I would like to invite Axel to present from the perspective of machineries in the textile industry, in textile finishing industry, I guess. Please, Axel.
Yeah, it works. Let me just sum up what I said yesterday. 50% energy saving is a realistic goal. And there are basically three sectors which we must look at. It's first of all the processes. How can we optimize the processes? And processes, I will come into more details a little bit later. Processes are related to how do I work in my production? Do I have a lot of idle times of the machine heating without any textile production? Do I have a lot of downtime because of some maintenance issues in my machine, for instance? Yeah? Because some maintenance problem, the machine may not be running, and it also creates loss in the company. Can I improve my maintenance in general to get a better output of the machine, a better efficiency? Those are all the process things. Other process things, in a sense, are also what we discussed before. Minimal application is also a process thing. Chemistry is a process thing, yeah? So those are all kinds of things we must think about, and here we have a potential of some 25%. So next area is the hardware area itself. So here we are talking about minimal application units, for instance. Yeah, we just heard there are not so many in the industry. If you are interested in making trials with minimal application, we do have a very good laboratory machine in our headquarters in Germany. So if you have an application and if you want to find out is minimal application an option for me, you know, you can bring the textiles and the chemicals, and we can make trials with minimal application to make sure that, or to verify if it's a suitable option for you. So of course we do have minimal applicators available in our product portfolio. That is all there. Other parts are energy efficient motors, heat recoveries, probably dryers which are more efficient than what you have today, which would mean upgrading the entire machine, or looking at heat recovery systems and such. And here we see once again the energy consumption, and as mentioned many times yesterday as well, the finishing, textile finishing is the most challenging part because there we have all this process heat. But we also have some electricity demand for pumps, for ventilators, motors to transport the fabric through a machine, etc. So we do have some electricity there, but for wet and dry finishing we mainly have process heat requirements. And that's a very big task because we are talking about a temperature when it comes to heating up water of some 80 to 100 degrees. And when it comes to hot air, we are talking about at least 150 degrees, and we go even up further to 210 degrees for heat setting. So this is our challenge, and that's the very difficult part, to substitute the process heat. And in this portion on the right side, lower right side, you can see the extent of the challenge, because the textile mill, which also consists of textile finishing, they have, if it's a small company, a process heat requirement of 5 to 10 megawatts, and if it's a large company, 20 to 50 megawatts. So that's really a lot of energy required for, and to decarbonize this is a very difficult task. But still, 50% is possible. Here you see the machine which we provide, stentors plus relaxation dryers. So if we want to go about energy saving, first of all, we learned today that we must acquire data, that we must learn more about the process, how much energy, how much process heat, how much electricity do we need for this process. And a modern stentor like this has energy consumption sensors, which will give you all the information about how much process heat, how much electricity have I produced for this particular production, for this particular lot. So this is all technology available. There's a standardized interface called OPC-UA, Open Communication, it's a standardized interface. And through this interface, we can acquire all the production data, the consumption data, in order to make this analysis for the optimization of all the processes. So this is all technology which is available today. Yesterday I also talked about heat recovery. So when we want to recover heat on a dryer, on a stentor, we have two options. The first option we should always choose is to recover hot exhaust air to heat up fresh air which goes back into the process. That's step number one. Step number two, after we have done this, is to heat up, to use the residual energy in the exhaust air to heat up water. And this water is typically required in our wet finishing department, where we do the bleaching, the dyeing, and bleaching, dyeing, and washing. Yeah? So let's look at this. For Harapan Cunha, this should be quite a familiar slide. Here you can see the integration of dry finishing and wet finishing. So what we have done here is we use the heat exchanger, air to air, to first of all recover the hot exhaust air from the machine, preheat fresh air, bring it back to the process. And then we go to the second heat exchanger up here, and that's the air to water heat exchanger. And this hot water is being utilized in the wet finishing. Here we see a continuous washing, bleaching, dyeing, not dyeing, washing, bleaching range. So we can use a hot water buffer tank in order to buffer this water. And whenever it is required in the wet finishing, we can retrieve this water, this hot water, and bring it into this process. So this is a very good way of interconnecting wet and dry finishing. And that's something which can easily be done on not only continuous wet finishing machines, but also discontinuous. So if you have a jet or a jigger or anything like this, it can also be done in the same way. Okay, I mentioned to you we can retrieve or we can collect all the consumption data from the machine. And now let's try to think about a closed loop approach. Why not simulate a production process before we actually do it? And we have developed this special tool to do a pre-simulation of a process on a stanter to get the optimal recipe parameters or the optimal machine settings for this machine. It's an online tool which you could also use for your machine. And here we can key in all the important data which we as a textile finisher have or need. And first of all, it's the fabric itself, the fabric properties, then it's the process, the chemistry which we are using. Do we do wrinkle-free treatment or whatever we do? Yeah, we key this in. And then we have probably 2-3 stenters. We select which stenter we want to use for this application. And then we start to simulate the parameters. Yeah? We try to find optimal parameters. And then this tool will tell us, like for the case of Harapan Cunha, we can run this process at 60 meters per minute. And then Jason will come and say, whoa, we are running it at 40 meters per minute or probably 35. And then we can determine, why are you doing this? Yeah, we have some salvage problems. Yeah, we have curly salvage, and we cannot really open the curly salvage at this particular speed. Okay, so what can we do about that? So either we can find a way to open the curly salvage in a better way, or we can go to a slower speed, but reduce the ventilation speed of the fans, or we can reduce the temperature in the dryer to come up to the 45 meters, which is possible on this machine. So we can do like a scenario analysis and determine the right production parameters. And then we can do right first time approach. Yeah? We have determined most likely the best parameters. And with these parameters, we go to the machine. But before we do this, I will show you something else. Here you can see we did a scenario analysis. We are back at Harapan Cunha's machine. We have the recipe which they are using today. They are going 45 meters, but they could actually go 60 meters. How much could they save if they would go 60 meters? That's one analysis. Yeah? The other analysis could probably, how much could they save if they go 45 meters, but reduce the fan speed and reduce the temperatures on the stander. Yeah? So we can make different analysis, and then we can, by the pushing of a button, we can determine, okay, how much do we save per meter, how much do we save per day, and how much can we save per annum? And also, what is the CO2 footprint impact of this change of production parameters? You know, all of this can be determined with this process optimization tool. And you can see here, in this example, we have really big energy savings. We have about 1 million, if we would run this fabric continuously, we could save up to 1 million per year in terms of electricity, process heat, and also if the machine is running, is better utilized in a better way. If you produce more output, the machine cost also goes down, because the machine cost, the hourly rate of the machine is being distributed to more fabric, so therefore the machine cost will also go down. So all the data, also the data of the machine cost, it's all inside this tool, and it will help you to get a very good feeling of how a machine must be set and worked. And another important factor is the know-how, which is today probably only in one brain, you know, in your company, because there's usually only one person who knows exactly how to run these and how to set these machines. If this person is ill or if he leaves the company, you lose a lot of knowledge. And this tool helps you to quickly acquire the knowledge from the system and to bring it back to the people if you have new people. So that is a very useful way of doing knowledge management as well. Okay. This is just to give you a feeling of how to, what we can achieve with process optimization. So let's now go to a step-by-step approach. What I would recommend a textile mill on how they can increase energy efficiency and step-by-step become CO2 neutral. First of all, maintenance is the most important task. You know, those are very low-hanging fruits. If the machines are maintained well, if you don't have clogged lint screens or clogged heat exchangers with lint and all of this stuff, if you maintain them properly, the machine gives you a much better output. It's like driving a car with very old tires and new tires, or driving a car always in first gear instead of shifting to fifth gear. So no, you can make much better use of the machine if you do maintenance, and that's a training issue. Next thing is look at your material flows. We don't have to do an energy analysis already. We can only observe what is happening in my production during a whole day. You know, is the machine idle? Why is it idle? What are they waiting for to run this process? Why are they not doing it now? So improve the material flow. Reduce idle times, queuing times, etc. And then we are coming to this recipe optimization of the machines. We heard yesterday looking at the chemistry is an option. Yeah, you can use other dyes which offer you better properties. You can use this simulation tool. Establish product know-how. Okay, that's number 3. Number 4 is upgrade the production machinery. We have mentioned heat recovery is an option, for instance, high energy efficient motors, etc. Okay, next step is to look at the power generation. This can also be done in parallel. We have heard before, there are many ways to look at your power generation, at your boiler. And of course, first you can try to optimize the settings of your boiler to minimize heat loss, etc. And if you want to go even further, you can think about replacing lignite with biomass. You can change to natural gas or biogas and replace your boiler with such a boiler. And then, of course, the ultimate step would be to go to a CO2 neutral power supply. And when you do this, you first start with the electricity of your entire factory, and only the very ultimate step is to look at process heat and how can I use renewable energy to replace a process or to create process heat from green energy. So here I have this shortly in a three-step approach. First, you look at the electricity demand, the total electricity of all the pumps and all the ventilators, etc. And for this, you could use solar energy, for instance. And then we come to the finishing itself, and there we have several options. When it comes to the process heat, as mentioned before, we can go to switch from coal, from lignite, to natural gas, because natural gas has a better CO2 footprint than lignite. But then you could also mix the natural gas with biogas. It's also an option. If there's biogas available, you can also make like a 50-50 mix of natural gas, biogas, or you can go to biomass, as described by Bernhard yesterday. And there are also some future systems, just to give you an outlook. Sector coupling, I don't know if you've heard of this word. Sector coupling is the idea which was also mentioned, I think, by the gentleman from the energy department. If there is a waste incineration plant not far away from you, or if you want to go into a second business, waste incineration, you could consider, okay, why do I buy a waste incineration plant? I make use of the exhaust heat of the waste incineration plant in order to feed my process heat to generate the process heat for my textile plant. So waste incineration is one option with the sector coupling. Or you could go into geothermal, if there's geothermal. Why not use geothermal thermal energy, let's say with a temperature of some 100 degrees, and a new technology coming up is high temperature heat pumps. Then the technology readiness level is not where we need it today, but it's at least an idea for the future. With a high temperature heat pump, which gets its energy from geothermal water, hot water, we can bring up the temperature level to some 200 degrees sometimes in the future. And another idea is small modular nuclear reactors. That's what they are doing for the big data centers nowadays. They are implementing nuclear reactors to create electricity for these AI data centers. And maybe in 5-10 years from now, maybe more 10 years from now, we will also have small modular reactors available. And maybe that's also just an outlook into the future. Last but not least, I want to point out to you, whatever ideas we have, we can implement with the technology which we have today. If you think about biogas, we do have burners which are suitable for biogas. If you want to go into biomass, you can keep your existing thermo oil heat circulation system, or your steam heating system, your boiler. You just fire your boiler with a different source of energy. You don't use lignite, you use biomass. So you can use the stander, the dryers, even in the wet finishing, you can use everything in the same way. It's just an exchange of the boiler. So even if you would want to go into heat pumps at some point in the future, we would do this with hot water, with steam. And even for this, we would have, technologically, the center would be ready to furnish it with a central heat generation plant with a high pressure heat pump, maybe with geothermal energy, whatever. So it's not a problem of the machines in the wet or in the dry finishing. The machines can be adopted to this. And this is just what I want to express to you. From the machine side, there are no constraints. We can do all of these things. It's more of a general doing or the central heat production, you know, how does that look like? How is your boiler being set up, etc., in your company? But with the machines, we can implement all of this. Okay, and now I think, sorry, I've used maybe 5 minutes more than planned, but I hope I could give you a good overview of what is possible. There are many things possible, many options are in place, and if you're interested to improve your existing operations, we are here. We as Brückner, together with the universities, you know, we can assist you on step-by-step coming up to this 50%. Thank you very much.
Thank you, Axel. It's interesting presentation how to solve the problem of energy in textile industry. I also can recognize some familiar faces from textile industry. Maybe you have some questions, you can keep it for later because we will continue with our last two presenters. We have first Jai to present about the photovoltaic. Please be mind with the time because, yeah.
You put your your information here, yeah? So, where's you?
Sun farm.
Ah, where's sun farming? Ah, here. There you are, Jay.
Thank you.
Yeah, that's not on. There we are.
Thank you, Ida. Good day to all the participants here. Where's the pointer?
Okay, pointer. Why you need a pointer here? Pointer here?
No, on the soft pointer.
This is a paint.
Ah, yeah.
It's just laser pointer. Okay.
Thank you. Yes, I have 12 slides starting with why renewable energy and the global perspective, and then narrow it down to Indonesian context and the related industry, the textile industry, and the integration of renewable energy in textile industry. So let me start with the, is it okay? Thank you. First one, what is this? So why renewable energy in the textile industry? So there are so many benefits, a list of benefits that we get and advantages, starting with economic and financial gains, reduce carbon footprint, enhance energy security, and sustainable transition to the textile industry. So let's analyze this chart in here. So this compares different sources of energy, not only renewable energy, but also conventional energy, the cost of energy generation as against a resource. If you take this one, this is the residential PV, and the cost calculated back in 2019. So the cost of 1 megawatt of units could be between $150 to $250. So this is how this chart is read. And the most interesting thing is in here, the cheapest out of all the energy sources back in 2019 is utility scale solar PV generation. So energy through utility generation, utility scale solar PV. So what does it mean? These are mainly ground mounted solar PV systems. So the next higher energy category is combined cycle gas turbines. So now what you see in here in shades of black and gray, their cost is moving up, while those one in yellow or amber, the cost of those are coming down. So this is what has been happening for the last 10 to 15 years in the energy market. So one good thing is still, the cost of solar energy has become the cheapest back in 2019. Now it is even more cheaper. And these ones, residential PV plus utility scale solar PV plus storage are coming down. So this is a very important thing in here. When the utility scale solar plus storage comes down, we can assume that we don't have to depend on the grid. The dependence on the grid will come down drastically. So the regulators have very little to play, very little to, in other words, restrict us going for renewable energy. This is what has happened during the previous decade. Solar photovoltaic PV has reduced by 82%, and wind has reduced by 39%. They are still coming down. They are still coming down very drastically. This is happening in this decade as well. So that is a very good sign in implementing and integrating renewable energy in our household as well as in the textile industries, So as a result of that, this survey done back in 2020, pre-COVID, shows that the net energy integrated during the year 2019, as per the statistics, shows that 75% of them are from solar and wind. So solar claims almost half of the energy integrated into the grids worldwide. So this is a very good and very trending, fast trending factor. And this gives us a lot of comfort in converting all our energy resources to very green energy resources. And finally, statistics-wise, I want to show you this important one. The stacks of pillars represented in here is for PV, and this stack is for wind. This one is for gas turbines, mainly combined cycle gas turbines, coal, and so on and so forth. So you can see that the stack in here leads away from the rest of the energy resources, because all these factors what I presented in my previous slides have mattered in leading or adding more solar power into the grids. So the growth is exponential. Growth is exponential comparing to the others. Why it has resulted so much better? We have better technologies. Technology is getting better year by year. Reliable solutions, financially feasible and climate friendly. And more than anything, it has delivered investor confidence. So this is the main factor in adding this much of solar PV into the market. If we take the potential of having solar PV or developing solar PV in Indonesia, as per the global irradiation map published by the World Bank, the average shows between 4.8 to 5.1 kilowatt hours per square meter per day, which is a very financially feasible percentage compared to the other parts of the world. So Indonesia has a lot of potential in developing solar PV as per the market and as per the research and the software-driven simulation reports that we have calculated for Indonesia. So despite that kind of a potential, where are we today? Today, the energy sources in the textile industry mainly provided by the PLN grid, which is a coal-heavy grid. And then coal is also used in addition to the electricity for other processes which have a lot of environmental concerns as well. Then the diesel is used minimally, that is to provide backup power, but not for machineries, but for lighting and the light applications. So the impact has been made because of that. The high energy cost, which claims to be 25% of the total production cost, which is very high, and making the industry in Indonesia is disadvantageously competitive comparing the other players in the industry, where others pay $5 per unit of energy, and Indonesia pays, the industry in Indonesia pays $9 per the industry. Now, key objectives of adding solar PV or integrating solar PV into the industry is, the list is a long list, but let's focus on the ones we have listed here. The low energy cost, cut pollution, utilize the existing rooftops, no need of adding any additional spaces or investing in additional spaces, boost backup power, reduce grid dependency, ensure reliability, and enhance sustainability. So when designing solutions for the industry, means the textile industry, especially in Indonesia, we have taken into the account of high-level requirement that we gathered from the manufacturing facilities that we visited, thanks to Mr. Jason and his team, and also Mr. Ajay and his team, who provided a lot of details for us. And then the analysis what we have done using various software tools, and also the evaluation done comparing the various different technologies as against the financial feasibility and the operational feasibilities. So the result is very clear, and the way forward is with solar PV rooftops. So if I am to repeat certain things, what I presented in my previous slide, solar PV has been the most economical energy producing system for the industry, and as well as the most reliable. So again, we don't need an additional space, less risk because of the mature technology and the ability to acquire capacity of personnel, trained personnel who needs to install and maintain resources, fast installation, and various other things like the installation can be maintained very simply by using your own resources or the existing staff, and long-term warranties, which are amazing. Long-term warranties are now provided from 10 to 12 years for inverters, for the electronic and electronics components, and also for panels, the warranties are 25 to 30 years. Where in this industry or where in the world you get a warranty for 25 years and above? It happens only in the solar PV industry. I haven't heard any other industry providing that kind of a warranty even for a hard metal. We have worked out one sample calculation for achieving 100% renewable energy in the industry of textile for Indonesia, taking the parameters and figures for Indonesia, for a facility which has 10 million kilowatt hours of consumption per year. So we assume that the factory we select has 10 million kilowatt hours per year consumption with an increase of 4% every year. And where we want to start by doing, we convert 4% of the conventional energy into renewable energy in the first year, and then apply 1.5 times of what we implemented in the previous year to the next year. So if you go through by this calculation, in the first year we had 269 kilowatt, and the next year we have to add 403 kilowatts. So like that we keep on adding our capacity year by year till we get this formula of energy generated by renewable energy for the 7 years period starting with 400,000. So by completing this table, we can show you that we have achieved 100% within 7 years. So the way forward, the roadmap is very clear and very simple and risk-free, giving us a very cautious approach to develop to a 100% roadmap. So we have ample time within the first 3 years, to learn the lessons and correct them and go forward to achieving 100%. The same can apply beyond 7 years. So as per the calculation we have done for 25 years, it shows that the net savings can go up and up even beyond 20 years. In short, as a summary, the capacity required for that kind of a facility, which has 10 million energy units per annum consumption, capacity required at the 20th is 13 megawatt power, and the investment, estimated investment is 9.5, and annual saving is closer to $500,000 per annum, average per annum, and GHG saving is amazing, 160,000 metric ton of carbon dioxide, with a net saving of 10 million, just about 10 million. These numbers can be improved a lot due to the cost which has been coming down for the last 10 to 14 years. And going above these economical and financial benefits, this is what it is, what a typical supply line looks at a production factory as of now in most of these operational environments. So you have national grid supplying to the main bus line of electricity and some diesel generators to complement certain backups. What you can do, you can add solar PV, you can add biofuel generators or convert some of your diesel generators to biofuel, and then add more biofuel generators, add even storage systems. So with that, gradually you will have multiple resources, mainly renewable resources, supplying your main bus line or the main electricity supply. So now that you have multiple resources, why not you develop a backup supply line to take care of your operations and add more value to your operations. Now, there again, since you have solar PV and battery storage system, primarily DC suppliers or the DC providers, the direct current providers, why not we have a DC backup line to cater small scale or the low consuming units such as computer systems, security systems, etc., or the mission critical systems. And we can wrap everything with a very good and AI-based energy management systems are now available in the market. So we can do that and move forward, and we can add a lot of energy saving and energy efficiency methods by integrating all these, what you see in this diagram. So this is my final slide. Like many successful industries, renewable energy too is built on three major pillars. That is technology, regulations, and the finances. So all three are at the moment moving ahead with positive trends. So that is a very positive and that is a very good sign. So in technology, the technology being increased with a lot of efficiencies coming into the technology, and a lot of flexibilities are adding into the technology solutions. So technology is moving fast, and regulations are getting better worldwide, a bit challenging in Indonesia, still moving in a better way, plus financing. So financing is, I mean, the banks are getting very comfortable providing loans or the financial facilities for renewable energy because of the proven return of investment in the solar PV investments. So with that note, I finish my presentation. So thank you very much for your participation. Thank you.
Thank you, Jai. Last, I would like to invite Bernhard, please.
So the last one of this session. The last attention, please. I try fastly to look for the presentation. That was the wrong one. So that should be the right one. Now we are going to another world, and I realized now that it must be really hard for you Because it is something about technique, something about photovoltaic, something about textile, and now something about biomass. So we are really interdisciplinary, and nobody of you knows biomass that much that we know, and therefore we make only something like a biomass assessment. I want to present to you because that is really important. Biomass, bioenergy, if you want to, as a company, to use bioenergy, then you have to know that bioenergy is part of bioeconomy, and this bioeconomy is needed everywhere. You are sitting perhaps on a chair with wood, or you have textiles and so on. Everything is sea inside, and each of these sea can be done by bioeconomical products. But these bioeconomical products should be done non-fossil. And then we have bioeconomy, and we have food, feed, fiber, and energy. So you are in a complex system with your bioenergy from quite a lot of other options you have. It is a competition. And so for this, as we heard often today, we have to think about resource efficiency, sufficiency, and then after that, we have to replace our coal. So it is all about defossilization. If someone is saying decarbonization, he don't know that carbon is everywhere, is inside. And please, for the students, I think there are some students over there, remember this, it is defossilization. We don't want to have the carbon from the lithosphere, from the earth. What is sustainability? I only want to mention two things. This here are the original sentences, and if you have the presentation later on, you can read it. But in the early 18th century, they said it has to wood and so on has to be used like that it has a continuous and sustained use. And that's really important, and you have to use the land in all the needs, in concerning all the needs you have. And all the needs means in our days not only use of wood and materials and energy, but also recreation and natural or biodiversity and so on. And then another guy in the early 90s said we have to think about future generation. So it's really worth also for the students to read this original definition of sustainability, and this original sustainability definition went into the bioeconomy strategy, here the German one, and you see that in the bioeconomy strategy all the goals of SDG are inside. And I don't want to stress this that much, but it's really important that you think about ecological harness, that you have ecological boundaries, but there are also human needs, and you have to bring it together. Please never look only for human needs or for biodiversity or something. You have to bring it together and think it together. That is really important. And then we have in European Union settled a directive, and I learned today you have it also here in Indonesia, and we have a biomass directive. And biomass is that for energy must be produced, processed, and used in a sustainable and efficient way in order to optimize greenhouse gas savings and maintain ecosystem services. And that thing is a little bit unbalanced from my point of view, this European directive, and there perhaps are quite a lot of problems coming now to Indonesia, like the European European Deforestation Act and so on, because it is mainly balanced for biodiversity. But as I said before, we have to balance it between human needs and biodiversity. And here is the follow of the transition to deciduous forests in Germany. You see two deciduous forests in Germany, from Rhine-Palatinate and north of Berlin, the other. And you see that we had before quite a lot of trees which are not deciduous, and now more autochthonous trees. And the humans has to be part of the nature as that is. And we have in Germany or in Europe now something like the wilderness, which has an own value. And that is to say, if you look only for the wilderness, then you don't have the needs of the people, and you bring it together, as I said before. The potential, if it comes now with these things in behind, I told you, to the potential, as first the people said we have a theoretical potential, which is, for example, all the forests you have. Then you have technical potential, you can only bring something out, and then you have economical potential. But that doesn't fit into the modern potential assessment. In a modern potential assessment, you have you assess the sustainable, available, and feasible potential. That is to say, and I will tell you later how you do it, you have market, technical, and ecological boundaries, but you have low boundaries and nominal boundaries and things like that. And you have this competition between the status quo treatment, which is now in place, and future treatment. For example, in status quo, from your sawmills here in Java, all the wood residues, the leftover from the sawmills, are going to the landfills. So it's no use. But in future treatment, there will be a use. And then, as Mr. Achai told me, if Mr. Achai asks to different sawmills, they speak to each other, and then the prices go increasing. So also, if now is no competition in between, in future there will be competition, and so you have to be careful with prices and so on, and you have to make long partnerships, long trusting partnerships. There's a competition, as I said before, between food, fiber, feed, and energy. And you have an import-export balance. I told you yesterday that there are some wood shells from the palm oil industry, and they are going to Japan. And of course, you can use it also here in your coal boilers. And so you have to look import-export, and you have to look for acceptance. I did it for Germany, and I had stated 23 different kinds of biomass residues. And these different kinds of biomass residues I looked for, and I stated which of them I can do towards gas, biogas, towards burning, like solid biomass, and towards oil. And then we optimized it and said we have something about 900 petajoule energy, which we can use in different kind of ways. And the most important way is industrial heat by 600 petajoule. And if you do such an assessment, it is really crucial to understand the economy locally and national. Locally, for example, there are waste pickers, and they want to survive. And these waste pickers are in the landfill, and they take the wood out and use it for their own purposes. So if you want to have acceptance, you have to deal with it, and you have to deal with these local things, but also with the national, because if they use it, this wood as a replacement of coal, it has much more purpose. And so there are these two kind of things. And that's the last, Neil, the last slide. You have a biomass assessment questions. And with these questions, you can assess all the biomass. You could assess also the biomass here in Indonesia for your company or for traders and so on. You have to ask what quantities are produced annually. Then you have to look for the annual distribution, because, for instance, in hotels they have sometimes times where are no people there, in other times are more people there. And if you use the leftover there for biogas, then you have to observe that. And you have to look where are the quantities generated. For example, the palm oil mills, you have to organize the grids to the palm oil mills or good streets to the palm oil mills. This kind of aspect you have to configure. And you have to look what happened so far with these potentials. Perhaps there is a market you don't know, and then the prices will increase. Because after that, it's about prices, and it's really tricky to state prices from market which is not, which is only informal or not ready now. And is there a further competition expected? Is also really crucial to know. Thank you very much. That was the world of biomass. If you want to know more, then please come to me.
Thank you, Bernhard. Well, we have all the speakers having the presentations. I'm wondering if there is any questions from the audience, maybe? One question, please, from Everscientex.
Oke, terima kasih banyak, Pak. Baik, bismillahirrahmanirrahim. Ya, assalamualaikum warahmatullahi wabarakatuh. Ya, selamat siang dan salam sejahtera bagi kita semua. Terima kasih banyak Prof. Ida atas kesempatannya dan selamat juga atas gelar barunya, Bu. Semoga bisa terus berkarya untuk di dunia tekstil. Perkenalkan, saya Irfan Sode Putra selaku Sustainability dan Compliance Manager dari PT Internasional Tbk. Mohon izin saya menanyakan dalam bahasa ya, Bu ya. Nanti saya minta Bu Prof. Ida buat mentranslate kepada speaker. Baik, mungkin saya perkenalkan PT Internasional Tbk ini adalah sebuah perusahaan manufaktur tekstil terintegrasi mulai dari mengolah biji plastik jadi benang, kemudian benang ditenun jadi kain dan kainnya dicelup menjadi kain berwarna begitu. Jadi segitu profil singkat kami. Kami ucapkan terima kasih banyak, tadi banyak sekali paparannya yang dari speaker sehingga kami di industri bisa sedikit tercerahkan gitu. Nah, dari paparan yang disampaikan, sebesar dari kami sudah melakukan apa yang sudah dipaparkan tadi oleh para speaker gitu, dan itu memberikan dampak yang luar biasa sekali bagi industri kami. Kami bisa menghemat jutaan kWh per tahun, kami menghemat sekitar 10% lebih konsumsi gas, dan kami mengurangi limbah yang sangat luar biasa dibandingkan kondisi kami beberapa tahun sebelumnya gitu. Dari sisi proses kami sudah melakukan penghematan yang sangat besar sehingga pabrik kami bisa dikatakan sustainable dalam sisi energi karena mengurangi emisi yang cukup banyak. Nah, namun faktanya di Indonesia kita mengalami suatu permasalahan di mana kami sudah memproses produk dengan sangat efisien. Kami sangat maju dalam hal ini saat ini. Nah, namun kompetisi dengan produk dari luar itu menjadi tantangan tersendiri bagi kami di perusahaan, di mana harga pokok produksi atau HPP-nya sendiri saja itu masih lebih mahal dibandingkan harga produk jadi dari luar negeri. Nah, mungkin dari speaker bagaimana melihat fenomena tersebut gitu, karena memang produk yang dihasilkan ya yang dilakukan kalau marketnya tidak banyak tentu saja tidak menghasilkan apapun gitu, atau mungkin ada saran atau masukan kepada kami sebagai perusahaan apa kira-kira bisa dilakukan sehingga kami bisa menghasilkan proses manufaktur yang lebih sustainable, tidak hanya dari proses tapi juga keberlangsungan kami sebagai perusahaan. Demikian, terima kasih banyak. Selamat siang.
Terima kasih, Pak. Okay, because of the time, I will only take this one question and also please little bit interpretation. So PT Everscientex is an integrated textiles. They have implemented the energy efficiency and it saves lots of electricity and then also the wastewater and etc. But the problem they have is that when they can claim that the company is already sustainable, applying sustainability, but they have to compete with the products from outside. So in terms of, say, the price and etc., it becomes higher, but it should be competed with others. Maybe some of the speakers can give the tricks or suggestions about how to cope or deal with this situation.
I'm not sure if I understood correctly. You say you're saving money. I mean, you're saving energy. You said, but still you have problems competing with companies from other countries, like China, for instance. I don't know. I don't fully understand.
Yeah, it is.
That's more or less the question.
Yeah.
This is a general challenge because in China, some companies do not seem to make like a economic calculation. They seem to have a different agenda or get subsidies from the government, or I don't know how they really calculate. They probably don't calculate the way you calculate, and profits are probably not.
Yeah.
So what can I say? How to cope with this situation? Either your government does something about these low-cost imports, because it's a challenge for all of us with Temo and Shein and all these companies importing very low-cost or very low-priced goods into all countries, also Germany. It's a disaster for the textile industry, and I think it's a governmental thing for the most place. And I can only recommend to you to hang in and wait until somehow this problem is being fixed. Those are my thoughts about it.
Yeah. I think it includes like political policy. Okay. It's done? No more? Okay. Maybe in the network time during the lunch, we can also have more discussion here. Also, Akil from APSIV maybe can talk more about this, but later in the networking time about the government policy and related to this situation. It is the situation that is faced by almost all in textile industries here in Indonesia. Okay, thank you. So I can conclude that from all the speakers from the INATEX projects, we have made or initiated some ideas about the energy saving. And then now the questions, how can we implement this and how can this give the benefits, especially for the finishing textile industries, that we can discuss more later, maybe in the other time. Thank you for all speakers, and that's all for this session. Thank you. Good afternoon.
Thank you to all hosts and all the speakers. Due to the time, now all the hosts and all the speakers may be seated now.
That worked well, huh?
Now we'll break for a networking lunch and poster session, and the lunch will be held at the 14th floor, and the poster is located at the back of this floor. Dan bagi yang sholat zuhur, silahkan menuju ke K3. And if you haven't registered yet, please register yourself at the 14th floor. And so please take your time to connect your fellow participants, speakers, and industry representatives, as well as explore the various posters displayed during the session. Please feel free to approach the presenters to discuss their research and findings. Please note that we will reconvene at 13:30. Once again, we will reconvene at 13:30 for the next session, so please be mindful of the time. We hope you enjoy this time to relax, network, and engage with innovative ideas presented by the posters. Thank you.
So, distinguished guests from ministries and embassy, dear guests, dear colleagues, dear partners, dear friends, I want to invite you for the afternoon session. You see it's a bit complicated after you have eaten too much and too good in this context. I want shortly talk about what we are planning for this afternoon. Before I invite the guests, the lecturers to come up. So the ESG team in the ENATEX project was focusing on the management systems, on the industrial processes, including the workers' perspective. And so we used, on the one hand, surveys and LCA to have an understanding what is the situation for the companies in Indonesia and to look deeper into industrial processes, how to innovate. And on the other side, we had interviews and observations and surveys with the workers and evaluated also the interventions. Why are we doing this? Man, organization, and technology are combined in their daily task. Yeah, you have to follow specific processes, you use specific tools and machines, and so you have a lot of best practices in science, but you have to bring that into the practice, and then you need the people and the understanding. Do they understand the technology and the processes in the right way? So I want to invite now to come up on the stage is Aslihan Mehmizoglu. She will talk on ESG methodology, again with a focus on occupational safety and health. I want to invite Kalina Sumantri. She was doing the research for the industry and the comparison with Bangladesh industry. And then I want to invite Radri Benedictus. He was investigating the sustainable behavior in the companies, how they adopt the regulations on energy savings. And the last one is Dr. Guido Reinhardt from IFOI Institute, and he is working on LCA management and is introducing the methodology here. Thank you for coming here. Please join the seat here. And maybe Aslihan, you will immediately take over, and you will, address the same things as yesterday, but from a methodological perspective. Oh, very interesting. I never saw me that many times at the same time. Do not know what is going on. Funny thing. So let's try. Ja, du kannst jetzt dann teilen. Okay. Good. Okay.
Okay. Great. Let's just quickly search for the presentation. Okay. So it's what? Okay. Okay. It's working. Great. Distinguished guests, honorable representatives of ministries and embassies, ladies and gentlemen, Selamat Siang. Thank you. Thank you so much for coming back from lunch and listening also to this session. And I'm really happy as a scientist that we also have the second day where we can more concentrate on the methodological approach and also to understand why we did what we did. So today I will just quickly go into the methodology in general, and I picked one methodological approach from all the things we did, which is occupational safety and health, and I also will use the opportunity today to give an outlook on further or continuing research. Oh, this is a bit... So I mentioned yesterday, for those of you who were not here yesterday, about the complexity of the topic of environmental social governance, and also gave 3 key OSH measures we did in this project, which were the especially the occupational safety and health measures. And as you can see, we needed to collect a lot of data, and on macro level in the beginning, so to understand the status quo, and on the other side, the micro level, which is on the level of companies and the operators or the workers. So today I will talk about OSH, and my colleague Kalina Somantri will continue then later with different data which we did on macro level. So why are we talking about methodology? It is really important, especially as academics, as scientists, to also understand that this is really important in research to determine reliability, consistency, and especially transparency, so the data we collected can be used in industry. So strength of research findings is a robust and well-structured methodology, ensuring that insights are not only accurate, but also actionable for sustainable decision makers in the textile industry. So what were our key challenges when we were doing this? So one challenge was that while the project was going on, we had permanently changing regulations, both nationally in Indonesia and also internationally. Another thing was, to be honest, this project is an energy project, so ESG was not the first priority in this project, but later on with the trust and the meetings and coming together, this topic also started off. Another one is, of course, especially in the area of occupational safety and health, ESG data or OSH data is really sensitive data, for example, like accident data. So we really needed trust building. Another thing is that there is a lot of, or let's say a lack of resources, especially in SMEs and small and medium-sized enterprises, where they want to do most of the things, but they don't have enough capacity to give or to employ new workers who could work on those ESG topics, like reporting. So, no, this is not working. No, okay. So as I mentioned, I will just focus today on the methodological approach of OSH. And here you can see it looks a lot very complex, but just to break it down, I want you to look on the first on the left side on the data collection. And there were a lot of things we did. So first of all, when we came to Indonesia the first time, I've been here now 7 times for this project, we needed to do a lot of walkthrough in a specific distance of time. So we have a lot of different impressions from different shifts, different machines. And what we also did was a hierarchical task analysis, where we really look at every machine, which process follows what, which work steps, where you break really down what needs to be done in a specific process. This is also kind of related to the task-related hazard analysis, where when we break this down of the task, we also look at the task separately, what are potential hazards, not only environmental hazards, but also human hazards. So a lot of different things, but of course companies already have data available, like safety data sheets, standard operating procedures, or like I just mentioned, the accident data. And in the middle you can see, based on this data, we chose specific areas of the textile finishing department. And based on that, again, the next step would be to develop an OSH measure. In this case, this is a training concept. So I will hurry up a bit because I was told not to talk too much. So just to give you, because this is very theoretical, but to give you more like an example, when we did collect the data, we realized in factories, you have everywhere posters, you have occupational safety signs, warning signs, hazard signs, and then you're like, what should the operator focus on? What is concerning him? Like, does he really need all of this information? So when we did the data analysis in the second step, we realized the workers and the supervisors have really a desire for compliance, but there is no structured, target-oriented approach, and there is an excessive amount of information, and overemphasizing minor details can lead to that critical hazards and safety measures are not that visible anymore. So for that reason, our OSH measure out of this was conducting trainings which only include OSH information nuggets, which are small and very, very specific information which is taught to the operator. So this is maybe very scientific or academic, but just to show you, we did a pre-test, then we did the OSH training, compared it with a control group because we want to understand that our training concept is better than a conventional training concept. We did in-training surveys. Those other green dots mean that we did several trainings, like around 7, and then afterwards we did a post-test to compare the data. So looking back on all of this, we can sum up that our focus was to have a participation along action research. So this means that we really wanted to include all stakeholders in this process, having them included in agenda setting, selection of topics, and the development of the interventions. And then afterwards, we derived our focal points, and then was the implementation. And of course, for us, evaluation is really important. So having an outlook on this, in this project, I didn't talk about this yesterday, but we also developed the ESG working model together with Professor Eigenstetter. And here you can see ESG is such a complex process. And this approach, which I just showed you here with the participation along action research, can actually be applied to every of these topics. So, for example, this could also be implemented to the area of developing sustainable, sustainable integrated SOPs. So, I was asked to tell you something about our new project, SDG Prime. This is a German-Indonesian project. So since we don't have that much time, I will just give you 1 minute of information on this. So this is a project for 4 years, 2024 till 2027. And SDG Prime focuses on joint modules between Germany and Indonesia on the topic of twin transition. Twin transition means we think sustainability and digitalization together. And here you see that is also called just transition, to think digital processes in a green way. And in this project, we will also have exchange money for students. So if there are any students in this room who want to go to Germany from Atmajaya or Polytechnic SDT Bandung, we have money for that, and they can apply to our program. And so yeah, I'm making a bit of advertisement for a different project, but I will use the time. So it's a lot of money actually. This can be really used for a good course. So, so if you have questions, come to me later if there are any students. So terima kasih banyak, and I hope we have more time to discuss together.
Thank you very much. This was a hurricane of a speech. Thank you.
Like 11 minutes.
I was really asking for making it very short because I want to have some discussion afterwards, like an action research approach. And now, thank you, Vasilihan, for your contribution. I want to invite Kiki to give you information on the data, comparison of Bangladesh and Indonesia, and what we can learn from that. You need some? You know how to use it? Here's the folder. And then you have to share it with Zoom.
Here? Okay, Bismillahirrahmanirrahim. Distinguished ladies and gentlemen, I'm very happy to be here because, this is my opportunity to be a part of Enatex team, and I learned a lot from this project. And I'm Carlina Samantri from STTT Bandung. I will present about the methodology on surveys, on awareness and implementation textile and garment industry. So, the motivation of the study is textile and garment industries are still one of the key industries in Indonesia. From Bapenas yesterday, we also know that textile industry is one of top 5 industry priority. And then the EU Green Deals and its regulation will affect the textile supply chain in near future, or even some of the regulations are already in place. And then the companies need to prepare for ESG management and due diligence processes if they want to export their goods to Europe and other countries. So, because of that, the goals of this research is to get some insights about the ESG performance in Indonesian textile and garment industry in reference to Bangladesh. Why Bangladesh? Because it's the most important supplier for the German brands. So we want to know the status quo and the gaps between current condition in textile and garment industry in Indonesia, and we as academia want to know what we can do to make the gaps shorter or even remove that gaps. And okay, this is the method. We use the online survey. The survey is collaboration between STTT Bandung and Indonesian University. And we use online survey in English and in Bahasa Indonesia. We use it in English because some of the textile and garment industry is like a foreign investment. So the responder are expatriate. And we collecting data from November 2022 until August 2023, and we directly contacting the companies. And the number of companies in each country, Indonesia have 42 started with serious answer, but only 41 completed all the questions. And in Bangladesh, the number is 55, but only 48 completed all the questions. So this is the benefits and challenges. To have the online survey, of course, it's efficient in data collections, and it's also cost effective, and because this is anonymity, so the responder can be honest, fill the question, because no one knows who fill what, and then it's like their confidential will be still confidential. Besides, I think there's no confidential data in that survey. And also, this is quantifiable on the results. But the challengings are low response rate. So we contacted more than 100 companies for the survey, but it's only 41 companies that fill all the questions. And then, sometimes we have to
do several follow-ups, like 4 or even 5 times follow-ups, again asking the companies if they already fill the survey or not. Yeah, that's become the another challenging. And also it has limited depth, because yeah, we only asking the close questions, and we can't dig more like we have interview. And yeah, this online survey also have misinterpretation questions. That's why I several times come to some companies to support them to fill the question. And there are also survey fatigue. That's why from the 47 to fill the question in the beginning, it's only complete 41. That's why maybe 7 companies feel this survey fatigue, yeah, because the survey is a bit long and need sometimes to fill it. Okay, and then this is the company profile of the responder. Yeah, from this data we can see that the type of industry in Indonesia is mostly separated. I mean that Indonesia owns less large and integrated company compared to Bangladesh. So only 17.5% from the responders has integrated from maybe from not fiber making, maybe from the textile until garment manufacturing. Yeah, if we see here that in Bangladesh, 50.9% are integrated companies. So this is like industrial sector engagement. So we divided into several industrial sectors. Yeah, from this that we can see that we don't have any waste or waste disposal or recycling commercial responder. But then yesterday I heard that maybe Pebble is doing that. Yeah, maybe for the it should be Pebble should fill the question, fill the questionnaire. I mean, yeah, maybe we have to update the survey and add the respondents, and yeah, maybe if we can continue the project with more responder. This is the export markets for Indonesian company. If we see here that we can see Europe is the most important market for Indonesian companies, and then followed by Asia Pacific and local markets. So in Europe, 75.6% that we sell it to Europe. Yeah, here from the survey we ask the responders, do they know about the regulation, or do they have the knowledge and the compliance about all of this all of this regulation. And some of Indonesian companies know about and already comply with international regulation, but still more than 50% of responders didn't know about that. And yeah, from this finding, as maybe informed by Aslihan yesterday, that we did the lecture series. We have 12 lecture series to as the answer for these findings. So we do the lecture series to make the industry knows about all of this regulation, and the participants is the ones that we send the questionnaire. So all of them are invited to our lecturers, and we also invite the students, our alumni, and the industrial practitioner. Okay, and then here in Bangladesh, if we see from the data that companies in Bangladesh are much better prepared relative to the upcoming regulation. So they, at least they know about the regulation. And if we compare to the to the Indonesian companies, the companies that already comply is much more than Indonesian companies. Yeah, this is, we also asked about the management system. And again, Bangladesh implement better in management system than Indonesian textile industries. Yeah, it's also same with the certificate. All the various certificate and initiative are much more common in Bangladesh compared to Indonesia. Okay, this is method and tools. For example, yeah, if we see here that 32.5% company measure their ESG performance through HIC index. Yeah, but it's still less than what Bangladesh had. And then this is for the due diligence grievance mechanism. It's also already informed in yesterday presentation by Aslihan that working grievance mechanism for human rights violation in Indonesia, it's well implemented, and this is it's better than in Bangladesh. Yeah, because maybe the human rights are integrated in society in Indonesia. Okay, and then this is the barriers of implementation. Lots of companies say that high implementation costs become the most barrier for implemented all the regulation or certifications. Yeah, this is the conclusion. The benefit of Indonesia are higher levels in human rights, but the Indonesian companies have to show their human rights compliance more. And then Indonesia should invest maybe in some marketing to promote their human levels compared to many other Asian countries. And the risks of Indonesian companies are mainly related to ecology. The same holds true for certificates and waste management. So yeah, we have to progress fast, because if not, Indonesia will lose their market share. Yeah, because some other countries already catch up with that. And yeah, the flood of certificates is real burdens, which means that careful decisions have to be made. And the last, maybe Indonesian companies have to invest in management systems like ISO, should be 50,001 and 14,001 for energy management and environmental management, and some product certificates, and maybe need some investment in technological innovations. They should support yeah, they should get support from government, maybe in here for to Ministry of Industry, so they can stay competitive. Maybe that's all from me. Thank you. Terima kasih. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Kiki, for giving us these insights, and hopefully industry will pick up this data to realize some more competitive advantages. So I want to invite Ratri Benedictus, Dr. Ratri Benedictus, to take over and to inform us over his research in sustainable behavior at the workplace. And also, he followed the action research design with asking the people, using the local wisdom of the people. And you start. Thank you.
Okay, good afternoon, ladies and gentlemen, distinguished guests. I'm very grateful to have opportunity to present our study, methodology on transformation towards sustainability. Actually, the findings already presented by Ibu Murni yesterday. So I just, for this moment, I will talk about the methodology. So, like Mr. Benhard Wern said this morning on his opening speech, that machine technology center transformation towards sustainability need to be followed by human-centered transformation or methodology. But unfortunately, that behavior change management has left behind compared to technology or system transformation management. That's why, like Mr. Fauzan from the Ministry of Higher Education and Research, promoting sustainable behavior need to be supported by establishing a behavior change ecosystem. That's why at least we define two research general question for our 3 years research. The first question is what factors influence the development of sustainable behavior based on the ecological theory from Brenner, that when we talk about the ecosystem, we have to consider about the multi-level dimension from micro, meso, and macro level to support the transformation of behavior towards sustainability. And the second one is how does transformational leadership lead to the sustainability? So this is the research focus based on the Brenner theory. From the micro level, we try to mapping multi-perspective meaning and motivation toward energy sustainability. And from the meso, we try to profiling, share values between people in community, and also about the norm and what kind of a social norm that they believe, and then resulted to the collective behavior toward the sustainability. And also we consider about the existence of informal community leader. And from the macro level, we profiling the leadership and also organizational readiness for change. So this is the multi-level approach to focus on our research. And this is the roadmap of our research. Actually, this research supported also from the Ministry of Research and Higher Education. We got 3 years sponsor for doing this research since 2022 until 2024. On the first year, we doing an explorative study with the focus on meaning mapping of sustainability, especially for the energy efficiency. So the simple question when we collecting the data is what is the meaning of efficiency energy according to the participants? And the second year, we doing some quantitative study. This try to identify influencing factors based on the result from the first study. And the third years, we develop a model, sustainability model, based on community and local culture. And last, in the end of the 2024, then we resulted a module design. So we have a module training toward behavior change. This is the detail about what we already done during this roadmap of the research. Doing explorative study in 2022 for the data collection, we used interview and also focus group discussion. And the participant, we involve internal and external participant. From the internal, actually is from the organization itself, from the operator until the leader on the organization, from the lower, middle, and upper level. And for the external group of participants, we involve the local government from the RT until the lurah. And the community group, we involve the women community group and also the youth and also the religious community group. And also we consider about the influence of religious leader. That's why we invite them to join on this explorative study. Because this is the qualitative study with the typical data is a narrative or descriptive data. So we use a thematic analysis and utilize MaxUDA to analyze. And this is the quantitative study. The data collection, we use survey by questionnaire, both offline or online, because some company need to be online to follow the data collection, and some of the variables actually based on the result from our first study or the explorative study. Some variables consist of values like biospheric values, egoistic values, and also altruistic values. And we consider also about the importance of the intention, before the particular behavior established, and also we evaluate a pro-environmental behavior among the participants, and consider also about the influence of leadership in the organization, also the moral intensity toward the sustainability, and of course the organizational readiness to change. And all the participant is the operator, so we try to collect their perception or their point of view regarding something that relate to the sustainability effort. And for the data analysis, we use correlation and regression tests. For the mixed study, this is in our third year's study. Actually, this mixed study try to make deeper and wider from the previous study. So actually, the data collection is combination between the qualitative and also the quantitative approach. We use interview, FGD, and also survey by questionnaire, but we try to get more participants in these steps. And also the data analysis combination between thematic analysis for the qualitative study and also correlation and regression test for the quantitative study. And the result already presented by Ibu Murni yesterday, but if you want to know some of them, you can see on the poster and behind, or you can read on the book that result already published with the title Ketahanan Energi dalam Cipta Karya Manusia Indonesia. So this is the model that we resulted, especially how to make or to transform the behavior among Indonesian people toward the sustainability. At the end of 2024, we already resulted a training module with the topic developing pro-environmental behavior toward energy efficiency based on local cultural values and organizational leadership. The objective is to equip leaders, because of the leader has a very strategic position, with the knowledge and skill to effectively promote and cultivate sustainable behaviors among employees in the Indonesian textile industry. And this kind of module consists of at least 13 sub-modules. And these sub-modules is based on the result from our previous study, and we have a very various method to doing this kind of training, like games, lectures, group discussion, case study, role play, and sociodrama. And this is the process that how we resulted the training module. At the first step, we design, and then we make some validation process. We invite at least 2 experts to make judgment on this kind of module. Of course, they have they are expert in the training and facilitation methodology, and then we make some tryout. We make some trial. And supported by Unika Atmajaya, when we by giving this kind of training to the employee of Unika Atmajaya, and then we finalizing the module, and we currently have the intellectual property rights for this kind of module. And this is what we will our plan for this year. We will do some applied study with approach quasi-experimental study. When we use a control group design with a pre and post test for the evaluation. So we try put this our module that I present before. This is as a independent variable, as a treatment to modify the sustainable behavior. So this is just an idea. and hopefully we can opportunity to involve some participants, especially from the organization leaders, especially from the organization with technology or system transformation toward sustainability. So we can combine or making a balance between technology, machine-centered methodology and human-centered methodology. That's all that I can present. Thank you. Vielen Dank für Ihre Aufmerksamkeit. Terima kasih.
Thank you, Ratri, for giving us these insights, and I'm really surprised that you already make benefit out of it with a training module. So I'm very happy about that. Guido, it's your turn. Thank you. Ich habe das Gefühl, du willst das haben, oder? Dass ich das starte? Ja, ich kann es. Okay. Reinhard. So. Okay, thanks. Ah, good. Good. And now. Should be possible.
Yeah, good afternoon, everybody. Great to have you here. And I'm happy to give a talk on the methodology of environmental life cycle assessment with respect to academia. So I just recognized this morning that in this room today we have almost the same audience like yesterday. So I didn't expect that, so I can very easily skip quite a bunch of my slides because you already know me, you already have seen some of my slides, so there is no need for the introduction actually, and also no need to raise awareness about the environmental implication associated with the textile industry, and I can dive into the methodological issues straight. And as I said already yesterday, we're talking about the life cycle of fabrics, garments, textiles, whatever is the goal and scope definition. And the carbon footprint is calculated along the whole life cycle. And as I also presented yesterday, the results are displayed in this kind of graphs. In this case, it's a cotton t-shirt from cradle to grave, and also compared to a cotton shirt from polyester. But what is the difference to yesterday? So actually, as a life cycle expert, I don't just calculate the carbon footprints, but I'm also responsible for the interpretation. And I would like now to ask the whole audience of you to raise your hands in two different kinds of interpretations this slide can be interpreted. Because if you would be a decision maker, or you would have the responsibility to interpret this slide, that is much more difficult compared to just listening to what a people standing in front of you is talking about. And there are two options. One option is because the carbon footprint of the cotton-based t-shirt is smaller than the polyester one, the interpretation could be, well, the cotton t-shirt is better compared to the polyester one. A second interpretation would be, well, it's very similar, they have the same level, there's not a big difference. So now I ask you, please raise your hands if your interpretation is that a cotton t-shirt is better for environment compared to a polyester t-shirt. I would like to see everybody who has this interpretation. Okay, Thank you. Now I ask the other question, and I expect everybody who did not raise their hand must raise his hands right now. The second interpretation would be there is no difference at all. It doesn't matter whether you buy a cotton shirt or a polyester shirt. So please raise your hands if this is your interpretation.
The second or the third?
Okay, so obviously there are also another interpretation possible. I don't know which one, but one could be that the polyester one is better compared to the cotton one, but this is not an interpretation out of this slide. But maybe this example gives you an idea about in which challenges we run if we produce results with a carbon footprint. And as we have a session on methodology, I would now like to dive a little bit more into the methodology of a life cycle assessment with respect to the textile and fabric and cloth production. And if it comes to cotton or viscose, which is bio-based, land is used to produce this biomass. And the first issue is water footprint, which we have to consider. And the reason is that if we look into the cotton producing countries, there are scarcities and lacks of water around. For instance, here in the desert, in the North African countries like Morocco, Tunisia, and Egypt, vegetables are cultivated in the middle of the desert using 2,000-year-old groundwater, which will not be refilled. It will be gone after a while. And in other parts of the world, like in California, there is a big lack of water since many years because of the citrus plantations, lemon, oranges, etc., but also almonds. And in Asia, because of cotton production in Uzbekistan, the Aral Lake is shrinking. These are slides from the last 30 years, so we expect in a few years there is no Aral Lake because of cotton production. So in different parts of the world, we have different issues concerning lack of water, but if we calculate the water footprint, it becomes even a little bit more complex because we also consider water pollution into the water footprint if we calculate the total water footprint. Concerning land use, we consider the land use footprint being extremely important. There are competitions between food and biofuels and biomaterials, and also industry and agriculture and forestry. So that is a must to be considered. And I guess concerning the phosphate rock footprint, there are not many people who have heard about that, but this is what we usually discuss in life cycle assessments since more than 10 years right now. The reason is that if we produce biomass, we need phosphate fertilizer, and we expect that in the future we need more fertilizer with increasing world population and increasing living standards. But if we think about that the origin of phosphate fertilizer is 99% by rock phosphate and not by organic fertilizer. Organic fertilizer is just 1%, and the resources, they are not endless. So there are different scenarios, but if you look at this scenario, it becomes to an end that in a few decades or 1 or 2 centuries, we run out of phosphate rock, and that means because phosphate is a big bottleneck in agriculture in the future, we include them in the life cycle assessment. And if we calculate for all these footprints the same life cycle assessment as I displayed with the carbon footprint, you have the results displayed here on the slide. And there you may recognize carbon footprint is almost the same energy resources, the fossil one as well, and acidification. But with the biggest bottlenecks in agriculture, which is land use, water, and phosphate, the polyester t-shirt outruns the cotton t-shirt by far. So my main message is out of this that there's the absolute need to include quite a number of environmental footprints into the methodology of life cycle assessment and not just concentrate on the carbon footprint. So this is my first take-home message of today, and best is to include all environmental impacts, but with respect to the textile industry, the minimum requirements are the 5 footprints listed here. Concerning the examples of life cycle assessments, as I already explained yesterday, we usually start with the goal and scope definitions, which are manifold, but we can sort them out in 3 categories. One is the complete life cycles and life cycle comparisons. I just skipped this slide because this is what we just discussed. And the second is processes, services, etc., which is just a part of the whole life cycle. And this is what we already discussed yesterday when I displayed the results from standards. You may remember these slides that there are different options to optimize technologies by efficiency or by technology, also with substitution of materials. And the other example is by substitution of providing energy, where a lot of carbon savings are possible. So actually, for this, as being in the methodological part of life cycle assessment, we have to distinguish the goal and scope question into process-based ones, or service-based ones, or product-based ones. So it really depends on the questions you have. And last but not least, the third field of action is factory-related goals. This is what I already presented yesterday. Today, I just want to explain a little bit more. You see the red line. The red line is the factory gate. But if a balance, a carbon footprint, or any other environmental footprint is performed for a factory, we also can calculate the emissions outside the factory itself. So we have emissions which arise inside the factory gate. We have emissions which arise outside. If they buy electricity from outside, then of course the emissions from electricity production must be considered. And this is what we call tier 1, 2, and 3. And in these fields, we can display the results later on to be able to distinguish between the emissions inside and outside, and which are associated with the chemicals and the fibers which are imported, in contrast to the energy issues. So just to give you an idea about how complex that actually is, because sometimes if you look at the results, it looks very, very easy, but there is a lot of methodological approaches behind the scene. So if it comes to the factories, the tier 1, 2, 3 is always an issue and a must according to the international norms. For my last message, I would like to state it's about the performance of an LCA. Again, yesterday I explained that because of the very complex options of the goal and scope questions and a lot of work to be done to perform a life cycle assessment, there's the absolute need to become an expert to actually work on life cycle assessments. But what does this actually need? And especially for academia, the consequence is that if you become an LCA expert, which needs 2 to 3 years, I would say, you have plenty job and career options in front of you. You can work as an external consultant. You can work inside the company in a department working on environmental or sustainability issues. You can complement actually working teams which work on sustainability because they work on social and economic issues as well. And as an environmental expert, you help actually to supplement the whole field of sustainability. There are a lot of options in science to develop methodological approaches which are still running inside the LCA community. For certification and reporting schemes, LCA knowledge is needed, not only how to perform an LCA, but also how to interpret the data, the results, and to identify the limitations of the results of the life cycle assessment. Reviews are necessary for international standard-based life cycle assessment. Database, the most important issue. There are a lot of people working on database management to ensure the quality of the data, and teaching and training as well. In Germany, for instance, we have 5 professors working on LCAs. They are teaching and training only on life cycle assessment. So these are the perspectives for academia and many options and careers for the future. So my summary actually is mainly that first, it's absolutely necessary with respect to the textile industry to look at quite a number of environmental footprints. And for this, it needs experts, and an expert, you have a bright future in front of you because there are so many options for jobs and careers in the future. So thank you very much for your attendance. And terima kasih.
Thank you, Guido, for being that inspiring and giving us a future despite being in academia. And thank you, all of you, that you have really kept the time, because I insisted as a moderator that we now have time for some interaction and for some discussion. Why that? We were talking about that we are also working with action design and the research approach, which is an iterative process, which means that we also learn from that what we have done. That means that we also address maybe some failures, some mistakes, or some vulnerabilities to learn for the future. And this is the most important process which we have working in sustainability, because we are going into an unknown future. And especially this group, and we are working with social scientists here in a technical environment. This is also, we are going above the boundaries. And so we are always in a terrain where we are really unknown, and so we had to learn from each other nearly every day. So my question is, so first to you, Ratri, what did you learn from Guido? What was the most surprising and most, most important which you could learn?
Okay. From
You're a psychologist.
Yeah, so from Guido, or from the material, the presentation of Guido? Because from Guido I learned a lot, especially about Heidelberg.
The presentation of Guido.
Yeah, okay. About the LCA. Actually, regarding the LCA is one of our sub module in our training module, and giving some insight. Compare when people have to evaluate or assess their consumption style and how many earth that needed for living. And during our tryout for our training module, mostly one participant need at least 3 or 4 earth for living. So it's give some reflection for them that they need to modify or need to refine their living style, especially for the consumption itself, food, clothes, transportation, etc. So thank you, Guido, for the LCA that you've given us during our workshop in Heidelberg.
We are in the tech, so you transformed it to the individual level. So Guido, I want to address you again. Now we have the trend in industry, in textile industry, that the people want to work on natural dyes. So you have already shown some specific topics which are related to life cycle assessment. How do you evaluate now this new trend working on these natural dyes like indigo, for example, which is grown on the fields, natural indigo, compared to artificial indigo? I know you don't have made any life cycles on that, but just you are an expert, use your gut feeling. What do you think about that?
I take this one. Hello? Yeah. Well, actually, the natural dyes and all natural bioproducts are not new, actually. It's an old story since the 70s, 80s, 90s. They have been replaced by fossil-based materials because in very many cases it's cheaper to produce. And actually, this is what we do since I'm in the scene with life cycle assessment on bio-based materials. This is the chemical or the word we use, that for each dye and for each bio-based material, we have to perform a respective life cycle assessment. And the outcome is very surprising. Sometimes the bio-based product is much better, sometimes it's worse. So you cannot really predict.
Mm-hmm. Okay. So it would be necessary to look into the future and to make life cycle assessment on the natural dyes so that we do not create a bad environmental impact here.
Yeah, definitely. And in Europe, we have the REACH agreement, you are aware about this, where all chemicals which are used in the chemical industry, and these are also the natural dyes and the chemical dyes, they must fulfill some requirements. And with this, over the time, it cannot be done everything within 1 year, but over the time we will have quite a good set of information for the society in future.
Thank you very much. Let's go to Kiki. Kiki, you're a textile engineer.
Yep.
And so you were suddenly jumping into social sciences. And what is your experience with that?
Okay, yeah, this is something new for me, and of course, I learn a lot. And sometimes I feel that I have to learn more because, yeah, I have to catch up with all the new things from me. But then the things that I learn is in this social science, I learn how the behavior, how the people behavior can make, like for example, improve the productivity in the productions, and then
what did you observe concrete that you see there's also a business case in it when we include social sciences in technological environment?
Yeah, because this is not in this project actually. I also have like what we call PKM, community service, and we did a community service in our campus, and then we observed that this social science with the behavioral approach can increase their productivity.
Oh, that's fine. You had made also a transfer into another topic.
Yes.
And
yes.
So this is my learning now that we have a transfer because never have time to reflect together on this. Therefore, I insisted on this discussion to have some new insights. Thank you so much, Kiki. Yep. So I would go to Aslihan because Aslihan, you mentioned that you are doing your doctoral thesis in the topic of occupational safety and health, and it's also something which was not your plan in the beginning that you focus on occupational safety and health. And what makes your change?
Oh, is it working? Yeah. Yeah, this is, I always tell this story that I studied in my bachelor's and master's textile engineering, but I never say I'm a textile engineer because I directly deep dive into occupational safety and health because it's so interesting that we're talking always about the textile industry challenges, but when you really stand in the factory and see the processes and the people working there, it's so interesting to look into their environment, their work environment, their safety, their behavior, their attitude concerning also not only safety, also what Michael Potzik told us. How much do the workers know how they can save energy? So it's really interesting that we go on a more small, or I'd say lower level, and look at the people working and who are most responsible for production. So I think I'm in a very good spot between those two, I say, science, between engineering and social science. I think it's a very exciting field, which will probably grow more, that not only in textile industry, I think in many industries we have to look at more the intersection between different disciplines. And I also want to say, I also learned a lot from Guido and also from psychology, from Ratri, from Kiki. I think our team, I really appreciate that as an engineer background.
So Ratri, what can we take from that for leadership? You were mentioning that you are making leadership trainings. What would you say as a general in our organizational culture? What do we need to improve the behavior to more sustainability? And it's complex, as we have learned from Guido. It's water, it is carbon footprint, it's occupational safety and health, and when we look at the 17 SDGs, it is even more. It's community science and to reduce poverty. So what can we learn to develop a good organizational culture?
Okay, just because, thank you, Monica, just because a leader has a very strategic position and they have a power and authority to influence their employees. So when they have a good perspective regarding the sustainability and in detail, like with the LCA understanding or maybe with efficiency, energy, etc., I think they can promote frequently. Yeah, even they can make some continuous improvement, like a strategic decision to the company, and then can shaping the supportive behavior related to the sustainability itself among the employees. But in this case, I think we need some consistent and commitment from the leader, so they can doing this kind of what is strategic decision consistency in their daily activity in the company.
So you are talking at the moment about modeling behavior, and I think this is a huge impact. What I'm always thinking about is also the next step, that when you are working in leadership, then you use a lot of gut feeling. And what I learned with LCA is that you're not allowed to use your gut feeling in many contexts. Yeah, it is counterproductive, and LCA gives you data, and it is sometimes paradox, and the opposite of that, what you have believed and thought about a specific issue. How can we train and help the leaders in industry to step back and say, yes, I have to learn more, I have to be humble, and I have to rely more on data and use science, a scientific approach in leadership. What do you think about that, Guido? What is your experience? You are working a long time in this issue.
Basically, one option could be to raise awareness about these issues. And the main question, but maybe how to raise awareness, because most people have lack of time, completely. So maybe we need strategies to find time for these people to take a step back for raising awareness. And at least in Germany, for instance, for most people who are employed, they have 3 to 4 days per year off for education outside their core business. And it's paid by the employees. And this type of strategy helps at least a little bit for the people to become open-minded for some issues you mentioned. And for instance, in our institute, we do have the same for the leaders of the institute. We have 3 days per year where we are in a closed workshop discussing about issues which are not directly related to our work, but to become more aware about these interceptions. And this is maybe one out of many options which are possible. So at least I think there are options.
Kiki, what do you think? You have also worked in industry. Did you have these opportunities to go outside and to learn and to improve yourself?
Yeah, I agree with what Guido said, that we have to build the awareness. And then regarding to your question, can you repeat again? What's
my question was how we can reduce the gut feeling and to improve more science-based improvements in the organizations.
Like what I said, that I agree with Guido that we have to build the awareness, and then maybe we can tell the leaders why we should like this, and then maybe we can also tell the benefits for the leaders and also the workers about what its benefits, and then they do it not because they have to, but because they want to do that. Yeah, maybe like that.
May I also add something? The reason we developed this OSH training was, I mean, we could have done in this project also a conventional training, right? Like we could have said there is a need for OSH trainings. Why should we develop a new OSH training concept? So the reason was we realized in real life when you're in a factory, they don't have time, like Guido said, lack of time. So how can we really say, like, take out all supervisors out of the factory, out of the offices, put them in one room and listen to our theory? We developed this concept and said, okay, we just need 1 hour of your time. We will do it in the most easy way for you. And they suggested something to us. They said, okay, we can spare 1 hour for you in a specific period of the day. And we took that time and it worked. And then they also said you can teach the operators between shifts. This is the perfect time because the shift changes. The operators are going to go out anyways. So it's kind of looking at their needs and adapting. I think that is, for example, in exemplary.
So you saw yourself as a servant of the
Yeah.
industry, as a
Yeah.
scientist.
Yes.
Very interesting approach. I want to ask the audience, are there specific needs from the industry which we should address here and take for further developments and further research in a textile industry or also in the other industry which are related to sustainability? Okay, so people are looking out for the next break, I guess. So let me then close with one question which every one of you should please answer. We have been working in an intercultural environment, and I remember the first year it was Corona time where we were doing a lot of online lectures just to keep ourselves in touch. And then we started the first meetings and discussions, and then we got a mutual understanding, and it was not without any irritations. What have been the biggest challenges in this intercultural communication? I would say nowadays we have made friendships, and it's a real deep connection we developed. But that this was not without stress, and I think this is also something we should mention, that interdisciplinary, and also these are different cultures, but here we have different professional cultures and different national cultures, which makes things complicated. What have been your main learnings, and thank you.
Okay, thank you. For me, maybe at the first time, because of the limited or the limitation of language proficiency, because for us, most in Indonesia, English is not our second language. English is foreign language. So maybe this has become one of the challenges. Yeah, but then again, this is what we learned, that this is now everyone use English, so we have to learn, we have to catch up with that, and we have to be like active learning, and that's what I learned a lot from this project.
Yes, from the psychological science, I think it's hard to understand about the textile, especially that consists of a lot of technical language, because in our daily life we only know two languages regarding the textile: washing and ironing. But now we have to understand from the whole process producing textile, and I think we greatly appreciate to Sritex and also Harapan Kurnia, and of course from other partners from consortium that give us opportunity to directly observe the production process and introduce us and explain to us about some technical language regarding to the textile. And the other challenge is how to collaborate with the different cultural background, like Indonesian, German. I think we have a different way in communication, and thanks that in our team we have Professor Hana Panggabian and also Ibu Juliana Murniati, that both of them is expert in the intercultural communication, so we can easily adjust with this kind of situation. Thank you, Monica.
You were prepared for the stress, which...
Yeah, we already stressed actually.
For us, we work since 40 years in 4 different continents, so we're quite well used with the intercultural changes and adapt to each of these perceptions. So there is no big surprise for me and no real big challenge. But I was aware that we do have the same challenge here, like with many other projects, if it comes to collaboration from academia with industry. Because the academia people, they understand themselves very well because they complement and they work together. But if the academics work with industry, you have to build up trust, because they are very skeptic at the beginning. They don't know you. They want to sell their products. Sometimes you need a non-disclosure agreement because they are not really sure which data they should share. So to build up this trust takes a lot of time, sometimes days, weeks, months. In the evenings, you drink some beers or rice wine with them, and then you become more acquainted with them. And after a while, this trust is built up. And also in this project, it took a while, but it worked excellent at the end. With all of the industrial partners, it was an excellent collaboration. But I was aware about this, and this challenge actually was solved fantastic. And we expect that with all of the project if it comes to industry, to be honest.
Okay, thank you. Yes, I totally agree with Guido. And I was just thinking that I grew up in an intercultural, or let's say multicultural setting. So for me, it's what I always say is you have to take the best from both sides. So I think this project was really successful because we differ in cultural points, but we took kind of both and the best out of it from the Indonesian side and the German side. And I think that worked very well, especially, I can't talk for all the groups, but in our group, it worked very well. And also that, like Guido said, building the trust also in the group, that when we discuss together, that we can speak openly. Like when I developed my OSH training, Ratri and I sat down after the pilot, and Ratri said to me, okay, as a psychologist, maybe it's better, I know it takes a lot of effort, but maybe to do it all in Bahasa, because those people in the trainings, they are not native English speakers. It will be a lot of work, but it will be more effective to do it in Bahasa instead of English. So talking about also the struggles openly, I think helps you, because if you ignore them, we can't reach our goals. But I think that was a good learning for me, that when you build the trust, you can be also open to each other and also discuss, the challenges and find easier solutions.
You mentioned something which is very interesting, because the German culture is something which is really rude in the eyes of the Indonesian, because we just jump in, here's a problem, let's solve it. And it seems totally unpolite, and we had to learn to take one step back. But what the Indonesian learned very soon is also to have this trust and to address problems and needs, and also to criticize us, which is very, very unusual. And even the people out of the industry were giving critics to us, and I really appreciated that as a huge trust in us, that we can deal with that and that we will answer to their needs. And I think this was a real success, and I'm really happy about that. So I wanted to sum up now. There are some benefits of social scientists, especially with the intercultural competence which came from the Atmajaya University. To integrate us, we have worked together on best practices in social sciences. When I look at the psychology, to use action research, to integrate the stakeholders, to have a lot of iterations to adapt our methodology. We had in mind the socio-technical system approach. We have used classical theories and implemented that and transferred that into the industry. And it's not really addressing LCA, but you have also your theories, and you were transforming that to us, and you see that a lot of transfer has been taken and adopted to these new environments. So I want to say thank you to every one of you. That was a wonderful experience to work together, and I'm really sad that this is project is nearly finished, and I'm so happy that we will have another project where we will continue together and build up these open educational resources. So we have another 3 years to work together and to deepen the friendship. Yeah, thank you very much. Big applause to my colleagues and friends. And I hope you enjoy the coffee, and maybe you take also a look at the posters and address some of us to discuss on the posters, and maybe also you came up with some new ideas on research and what we should develop. Now with this new project, and also with this additional money was mentioned by Ashlihan, is we have the opportunities to send master students, not many, but selected master students to Germany. They can also work there in industry or in the ISAs if they want. They can study at our university. And we have the option to send also German students from the textile department, also master students, to Indonesia to work in the industry or at the university. And therefore, please make contact with us. We really want the exchange to develop the exchange together. Thank you very much.
Much for all speakers and hosts. And now for the token of appreciation session. I would like to invite Dr. Muhammad Widodo from Polytechnic STTT Bandung, and also Professor Dr. Ida Nurmadhani, SSI T MSc, to the stage, also for receiving the token of appreciation. And the token of appreciation will be given by Mikhail Posik. And welcome Mikhail Posik to the stage and present the token of appreciation. Thank you for all speakers and also the hosts. And before we continue to short break and networking coffee, I would like to inform you an important message. I should inform this in Indonesia. Telah ditemukan e-money mandiri bergambar princess. Bagi siapapun yang sekiranya mempunyai hal ini, silahkan ke saya untuk mendapati e-money ini. Terima kasih. And now we will begin the short break and networking coffee and poster session. So please take your time to connect with fellow participants, speakers, and industry representatives. Please enjoy your coffee and don't hesitate to network and discuss the ideas that have been shared so far. We'll resume shortly, and so please make sure we'll be back by 3:30 p.m. for our next plenary session. Enjoy the break. Thank you.
Check, check, check. Okay. Check.
Thank you all for all participation so far. We are about to kick off our final plenary session, the third plenary. Now I hand over the stage to our host, Khadija Vela, who will lead us through the concluding discussions. Please welcome her.
Thank you very much. Ladies and gentlemen, I'm now opening the last plenary session. This is about the rollout and the perpetuation of our project Joint Results into the Indonesian textile industry and the academic sector. This session today will summarize all of our findings again together in order to find here key elements to transfer into the academic and scientific world, but also to implement that into the textile sustainable industry sector. Today we would like to focus on this specific kind of knowledge transfer between research and industry. Because this initiative, this collaboration, bridges a sort of an interdisciplinary collaboration to drive this sustainable transformation. Through education, research, and industrial partnerships, we aim to enhance sustainable transformation in Indonesia, Germany, and all around over the world. Therefore, we would like to see here the fruits of our activities of the last 4 years in order to explore again our key outcomes of the project and how to integrate that as an outreach, as a perpetuation of that into the university and industry scientific era. Therefore, please let me welcome also later on our key stakeholders with whom I will then discuss. And I would like to open later the stage for our kind and honored representatives of the universities. This will be the Polytechnic University STTT Bandung, and of course our honored guest and host of this ceremony, Atmajaya University. In person, represented here on stage then by Mr. Mohamed Widodo and of Mrs. Juliana Moni. From ITSIS, the project lead, Mr. Bernhard Wern, will be on stage. And from the German University, Applied University of Niederrhein, Professor Dr. Monika Eigenstädter and Mrs. Evelyn Lemper, I would like to come over then later to stage. But before we are opening this panel session, I would like also to go with you through the program. And of course, we have one external representative as well. She will also join the panel session, of course. And this is Mrs. Anissa Fitra, the head of Science and Technology Division of the German Embassy in Jakarta. Thank you very much for joining us the second day of our conference. And yeah, with your speech, which is about scientific and industry cooperation for implementation, you will give us also the values from an external perspective of a bridging institution between research industry here in Jakarta and also between Germany and Indonesia. Thank you very much. I will start now this session with a 15-minute short wrap-up of today of the key findings. The key takeaways from the so-called previous sessions, but with a specific view on the academic industrial rollout and the long-term adoption of our investigated sustainable practices for the textile sector. In general, we would like to empower the sustainable economic growth for the sustainable textile sector in Indonesia, in Germany, but also abroad, through research-driven sustainable transformation. This is what we did all over the last 4 years now, the collaboration between industry research and universities. And our outputs are, in general, to say what we could implement is a sort of an empowering and strengthening of the human resources, the skills of the humans, of the people who are working in that sector. Also, we brought fruitful outcomes for the science and education in order, in that way, that we achieve gathered data which have not been available, detected also challenges, obstacles which we eventually had an idea of, but became also approved. And we did everything together within our partnership to allow and to boost the green innovations within the textile sector, because innovation normally means also savings in terms of energy consumptions, for example, but also with other environmental impacts. I started here with the people, with the human skill resources, and I would like to end that first pillar with human behavior also, because we also conducted a huge proportion of our research studies on sustainable behaviors, because a change can only happen when people are convinced, aware, and taking it ahead with themselves, in their heart, in their mind, in their activities. And therefore we had also brought insights into the scientific outcomes on sustainable behavior assessments. This everything will add enormous and tremendous values for the scientific community, because we will disseminate all of our activities and our findings so that it will be open resourced for all these members of the scientific group, but also for the textile industry. On the case of two companies which have been partners, or which are partners in our consortium, Harapan Kurnia and also Sritex, they added also values because they got an inside assessment of their whole production site. This is not enough to make it just for two companies. Of course, the transfer to other companies, to the total industry sector in Indonesia, but also abroad, will be delivered under taking care of sensitive data, surely, and that will be done over dissemination and further activities. Nevertheless, again, or in particular, the collaboration with communities is also here adding values, because we want also to bring our insights into the regional and local communities, because regional and local communities around industrial areas, they are living together, so they are co-living together, and therefore it's very important that we're taking concerns and also values from them into all of our industrial sustainable activities. What will we realize with all of our activities? Hopefully, you will also testify this to us. We are doing primary research also in some aspects. We will contribute to high-class research, international high-class research, and transfer these findings into the academic and into the education sector to allow a widespread of all of our outcomes. And in general, we have already established partnership and cooperations between industry, academic, and government, but this shall be enlarged because we all have to work together to implement this sort of change. I would like now to just integrate or summarize the rollout and the long-term adoption of these sustainable practices in the textile sector. Out of our Enatex project, I have summarized this. Where are the fruits in detail? And this I would like to present. In terms of the academic education, we could gain here interesting input for the study modules, for the curricula of the universities, which are dealing currently either with textile, for example, production, or dealing with sustainability sciences. But here one outcome is that we have to work together, and that shall be reflected also in the curricula. That means we have to do a combination, an intersection within the disciplines, and that shall be reflected in the curricula. That means we have to integrate sustainability aspects out of our research across the curricula. That means we incorporate sustainability modules into textile university programs, and vice versa, textile sector specifica into sustainability study programs. Because sustainability university programs quite often are facing or working with other industrial sectors, but not all of them are touching this specific subsector like the textile sector, which is causing so many environmental loads. And this is also our mission, that we are making really aware that the textile sector is one subsector to be elaborated also within sustainability science curricula. Further, how we had realized all of our activities amongst the partnership, like you heard, we had emerged a lot of new methods or adapted methods. We did lab scales trainings or trials, and also we were conducting together with the partners, with the industry partners, best practices in sustainability activities, in the ESGs. So that means this we would like to transfer back into the curricula, so that these sorts of methodologies and trainings or trials and best practices find a place in the curricula, in the modules as well. Further, one fruit out of our cooperation is that we realized again that university-industry collaboration is really worth to go ahead, especially with perspection, with the view of the academic sector, because by developing joint curricula, we should address the real-world situation, the challenges of the industries, that the curricula and the modules are directly related to actual targets and objectives from the textile sector. Further, the industry will support us in the academic sector by providing, for example, thesis, master thesis, bachelor thesis on sustainable solutions on case for students through this enhanced university-industry collaboration. So we want to make the students ready to work with the companies directly after their studies. And in general, of course, to expand also academic partnerships, we have now, meanwhile, and also before that project already, a quite lively German-Indonesian academic partnership. But out of this research, we would like to establish also new university collaborations and student exchange programs, because the textile sector is not only happening or performed in Indonesia, but in many more countries with the same or even bigger environmental impacts. Coming now to the specific part, to the research and development aspect for sustainability. We have conducted so-called applied research on green innovations, which shall be then also go to dissemination channels in order to allow here an ongoing process for further research and development on the green innovations we have already implemented or investigated. And all of our data, not all of our data, all of our findings, beside, of course, excluded the sensitive data of the companies, we want to open and promote for an open access knowledge sharing. So that means that also other companies, universities, the science community has an access on our outcomes in order to multiply this later on. From the research aspect, from research, it will hopefully comes also a step ahead towards research-based startups and entrepreneurship in green tech or in textile sustainability processes. We hope that we can also contribute to this point with our findings. And in general, to go ahead, it will be on the one side academic-driven, but on the other side also industrial-driven, because there's a big need for that. But one important thing is also that we have all to secure funding, further funding, for so-called sustainable research and development projects. And this we could already realize with our Enatex project, so that the university collaborations between Germany and Indonesia have successfully applied and got approved a project under the German Academic Exchange Service. This project is called SDG Prime and is running for 4 years. Between 24 and 28, and this is about the the ongoing assessment and activities on the research based from the Auge Institute and the universities from Indonesia, Atmajaya and STTT. And so we are looking ahead on the results of that the next years. Thank you very much for this effort to apply for funds. It's always a big issue. On the last point, again, the personal development, so talking about human, but here with perspective in organizations, of course. So we provided also specific target-oriented trainings for leaderships and for employees on sustainable behavior practices in different disciplines. And everything is about to foster an organizational culture on sustainable values, addressing the cultural values. And addressing that or emphasizing this aspect is very important for the long-lasting effect so that it will get implemented into the company, also this sort of company culture, and that you get the people with you. It's very important. Our research has proven that we are addressing also the sort of a convincing element by addressing the people, the employees there, and this will be related to their values from their cultural, religional, and personal contexts, so that we are engaging them. And a company is not standing alone. A company is always situated in the context of a local or regional community. And here, one of these outputs was also that when we are going ahead with this research and with the integration into the academics, is to engage the communities in these academic industrial initiatives. Therefore, it's a lot to do, but a lot has also happened already, and it needs continuous improvement because we are just in the beginning of it. That was that in general to say, and that was a little bit more theoretically. But now I want to give you some examples that fits to these key points which I was just stressing. The examples coming from our research subsections in that way, from the partners, and I would like just to present the key outcomes for the academic rollout, which we have figured out in terms of energy efficiency transformation in the textile industry, here on the point of thermal energy supply. On that topic, of course, the objective has been that we have to perform energy savings, and we conducted potential energy savings by efficiency measures. And they are getting more and more important in futures as part of the textile machinery maintenance and operation aspect. And therefore, we will translate this in short term into trainings of optimal machine operations and also in energy and environmental performance analysis, so that the industry will be enabled, but also the universities within their programs to teach these elements of these trainings on energy efficiency in the thermal energy supply. In the midterm context, the integration of this aspect will be realized in a curriculum at the STTT Bandung. This is already set. And also the lab equipment for energy efficiency and to allow further research collaboration has been also realized. So therefore at STTT Bandung, which is focusing on textile study programs, the start of this integrated academic performances has been already done. In long term, these involved partners would like to, of course, allow the students to conduct master and diploma theses and to conduct semester trainings on energy management and efficiency because they would like also to establish even more relations and partnerships with the industrial sector so that the students can learn on case. In terms of the energy saving potential in the textile value chain, it was also again proven that the maintenance culture in the companies is very important to save energy efficiency or to activate energy efficiency potentials. And here the trainings, also the company of Brückner was raising that up, that this will be very important in order to save carbon dioxides in the processes. And this is the point, that here these trainings in the companies at the machine, they will be realized by having training modules and to get trained in the industry for the employees, but also in the universities and in the educational sector. The material flow management, of course, within the companies has to be improved, and therefore this sort of knowledge should be also transferred into curricula. And the production machineries, the upgrade of that to increase energy efficiency, of course, is also one big pillar to allow the sustainable transformation. But this is more a sort of a long-term realization target. But in between, these other points will be surely become an important point in the new to-be-developed curricula. In general, by doing so, of course, potential savings of 50% up to 2050 are realistically. This was one of the outcomes, but it must be implemented not only into the textile industry, but also into the people who get trained on that. Our findings on the solar photovoltaics integration under the topic renewable energy transformation also showed us what is important and what people in industry and also our new professionals at the universities need to get taught. And this is about the energy management in a company. We have to transfer skills that students and industrial operators can get data on the current status quo, on the energy consumption, so performing a consumption analysis, and also a cost assessment of the current energy system. From this point on, you can conduct also a renewable energy strategy by running feasibility studies on solar PV integrations. And here it's very important that also knowledge will be transferred about scalabilities and scalabilities in that wise. So the transition towards 100% renewable energies cannot be done from today to tomorrow on, but many renewable energies allow to have a modular implementation option. That means you can implement it from time after time. And that's quite important also to teach to the students. In terms of policies and regulations, of course, we need to transfer also lectures in that way that you are getting skilled on the market situation and on the subsidy situation. That means which incentives are existing in the country you're working with, and that should be also included interdisciplinary in the curricula. In terms of another renewable energy aspect, it's the valorization of biomass for bioenergy and maybe also material biomass use, but in general for the energy offsetting. Here it is important out of our research that we are transferring the knowledge on the methodology to conduct the biomass potential to valorize biomass from the region, for example, that would be the best from sustainability aspects, into the heating and electricity supply systems of a company. And there are specific methodologies existing. It's called the material flow analysis, which we have conducted. And this is about analyzing the biomass residue or waste potential. Here you have to be skilled on mapping the resources and identifying the local energy demands, and also which sort of optimal technologies for industrial use are in place. Of course, also running economic viability calculations, like, for example, cost-benefits calculation to implement the system. And when we're talking about biomass, it's very important on a global scale that the regulation and definitions on a sustainable biomass supply will be compiled with. Surely here as well, policy and market, all incentives, regulations, tariffs, and maybe hindering or supporting aspects to, for the supply chain, for the management of biomass from the source to your company are very important to get, teach to the industrial operators and also to our future experts. But biomass eventually cannot bring you all the quantities you need in your company for energy production, and therefore you should always think more integrated, and solutions like combined heat systems, for example, biomass with solar or other hybrid systems, should be taught as well in the programs. When we are coming now away from this sort of technical and resource-based approaches, I would like to take you with me into the sustainability transformation outrole of our research. And this is again about people. And we have conducted many studies pretty much led by the Indonesian Atmajaya University, but also with Auge Institute on the ecological behavior. And here, as key outcomes for academic and industrial rollout is to implement these sort of methodology, how to conduct that at organizational level, but also in the teaching environment. And what needs to be trained is that we are understanding why we are behaving how. And this is understanding which influencing factors at micro, meso, and macro levels are steering our sustainable behavior. And here, therefore, there are methodologies existing, how to conduct this. And this we learned in our project from our partners. And that shall be also transferred into the curricula also at Atmajaya and in Germany, HSNR, and in other universities in midterm timelines. These will be data-driven methodologies and combined with practical applications. And we have in the project already disseminated training modules, which are then referring to these sort of methodologies, but further dissemination will also arrive. Also, to headline is that surveys as a methodological tool in the industries of the garment and textile sector were conducted in Indonesia and Bangladesh, and this was added by on-site interviews. It is very important when we are transferring this knowledge on how to define such a survey, for example, how to conduct it, to headline here also to the people who are running that later, is that the direct engagement with the companies where we are relying on the data is so important, because if you just send out a letter with a survey, you will get a very low feedback response. And therefore, you have to do it again, talk to the people, phone with the people, make face-to-face interviews. The more you more energy you put here inside, the more you will get back. And that's a very interesting outcome, which should be directly transferred in the teaching, not only how to conduct a survey, but also the way on how to address the people to get a higher feedback loop. In terms of ESG management, we have here two pillars. I would like just to say that within our project, we conducted here diverse methodology approaches. So it was more a theory-based development of methods, compiling a multi-method approach for quantitative and qualitative data, but also an action research approach where the stakeholders and the local wisdom have been included in order to adapt the research process for joint reflections. This is everything under the so-called socio-technical system approach, because we heard about many methodologies to get data and so on, but here it's more about how people are reacting in our system, and therefore we have to do here the ESG management together with the people. And this is the one part. And within our project also we have the life cycle analysis. This is on that page or on that stage to add on, because on the left page you see here this applied psychological and human factor research, talking with the people, understanding the behavior, is on the one hand a very crucial aspect. And if you would like to add that up with data and facts, so the ISO 14040 with LCA settings need to be tailored so that you get here direct data and facts to cross-check also or make other assumptions out of your outcomes. These different but also aligned methodologies shall be also integrated for further uptake. And therefore, I would, and with this sense, I would also like to end this short wrap-up with the life cycle assessment as the tool, as the perfect tool, eventually also to identify the environmental implications associated with a product, process, technologies, and services in order to achieve here direct data and on quantitative level for the companies, that they can also assess their performances from the status quo towards the improvements. And since LCA is a very powerful and complex tool, it requires really experts to carry that out. And therefore, this is the task which we are giving back to you, to the universities, that you should really implement a module on LCA that future experts can understand, can work with that to carry out also LCAs. And the market is really big, like we heard from IFA Institute, which are experts in Germany for that. So internationally, there's a very huge and great job opportunities existing for LCA experts, and which is really elementary to account also the environmental performances within a company. That's so far from the wrap-up. And adding one thing, we had also after each session today also the so-called panel discussions. And I wanted just to summarize and reflect some of the main points we discussed there. I could not get everything, of course, but hopefully I can touch it a little bit. And there was a very important question from a company representative out of the auditorium, and he asked us, how can sustainable textile companies who are running already their production more sustainable can be competitive on the market with the prices. And this is really a very big issue that we discussed also at our agenda today. And not only that, but also according to the interdisciplinary cooperation, we had some interesting inputs that we have to, when we're working all together, to enhance awareness and a better understanding for intersectional specifica, because when we're talking about sustainable transformation, it's always intersectional, and we all have to get trained additional on the intersections within our expertise. That's very important to go ahead. And the last point to stress here is that to go ahead with all of our activities, eventually in person, eventually with our institutions, but also to allow this transfer to the full textile society on a global scale, we have to announce and have to stress that the academic industry collaboration need also time for trust building. And this we have to invest, this time, for getting a long-term impact. Because without collaboration and without a sort of an openness on data availability and collaboration activities in general, we will not manage the full change of the system. That's so far from us. Thank you very much for this audience to the summary of the pre-slots. Rima Kassi, and thank you. And I would like now give the microphone to Anissa Fitria, the head of Science and Technology Division from the German Embassy in Jakarta. And her speech will be about scientific and industry cooperation for implementation. Thank you, Ms. Fitria.
Es funktioniert nicht. Muss ich was klicken? Achso, ist aber jetzt nicht auf dem Schirm, oder? Achso, das weiß ich jetzt nicht. Sorry, we need headphone. I can see it. Achso. Oh, okay. To log in there.
Oh, where is this? Okay. Yeah.
It's okay.
Yeah.
Should I start? Yeah? Okay.
Maybe if you can talk.
Yeah, I have my... So, yeah, my presentation is... It's in queue? Okay. So I will start. I know that that's really a long, long day, and I think we all already exhausted. But I think we have really much knowledge and also ideas in our mind, in our head now. So I will try to present my presentation just short as possible. I don't know, maybe I will introduce myself once again. My name is Anissa Fitria. I'm the head of Science and Technology section. It's okay. Sorry. Hey. This one. Mm-hmm. Okay, thank you. Yeah, so my name is Anissa Fitria. I'm the head of Science and Technology section at German Embassy Jakarta since 2022. Today I will try to present the significant strides in Germany and Indonesia cooperation in science, technology, and of course, and industry, and try to highlighting some joint projects and in many fields. Okay. Oh yeah, okay. So before we begin, I will try to explain. The German research system is built on a robust framework of stakeholders, including universities, research bodies, consultative committees. So if you can see, there are so much institutions there, and what I want to highlight is I don't know, you can read this good? Okay. So the research and development industry in industry. This is really important for Indonesia, for Germany, because this is the really major stakeholders in facilitating bilateral research projects. So I think I will skip this also. Or maybe you can see also this is the research and development in companies. We can see that the private companies, the industry, research and development efforts accounted for more than 75 billion in 2019. This is also highlighting the significant role of a private companies in innovation and also commercialization. So yeah, this is also the 6 missions that we have from under BMBF.
we have 6 missions. One is strengthening social resilience and diversity. Second, in improving public health for all. The third one is the fostering sustainability in energy, environment, and also industry. The fourth, strengthening Germany's role as a global innovation leader. The fifth one is actively shaping transformative processes in science and society. And the last one is the promoting new talents and innovation pathways. I think this is also aligns with the new Asta Cita priorities in Indonesia regarding the new government. So back to Germany and Indonesia cooperation, we have a political framework. Actually, this dates back to the 1979. This is really old. That's why I really hope that we sometimes can renew this political framework for our goods, for our science and technology cooperation between Indonesia and Germany. I try to talk to both sides, so Indonesian sides and also to German sides, that we have that we try to have another this science and technology dialogue and as soon as possible. So let's hope. This is also an overview of German-Indonesia cooperation. So we all know that Germany is Indonesia's largest European trading partner. Over 250 German companies operate in Indonesia and employing more than 200,000 people. Areas of cooperation include renewable energy, Industry 4.0, education and also health technology. And the German embassy here in Jakarta acts as a bridge, as I said yesterday, for industries, for businesses, academia, and also policymakers. This is the highlights of the cooperations in science between Indonesia and Germany. I forgot to add highlights from last year and also from this year. So from last year, from 2022, we had a final conference of the latest successful project between RWTH Aachen and also UGM, Universitas Gadjah Mada, in a project named called Gate Insit Zero. This called German-Indonesia Geo Campus in Indonesia for Competence in Education and Research for Organizations. So this project is also highlights the importance of academic exchange in shaping future technologies, especially in 4 clusters: environment and water, sustainable georesources, geohazards, and coastal risk. And the last one is energy and raw material efficiency. So last year we had also 2 projects also from the client too. It was the tsunami risk and also the Strat-Or. So it was last year, yeah. So we'll skip the other highlights. I think it's all you can all see. So this is the key areas of cooperation. I try to combine from both sides, from Indonesian sides and also from German sides, because I think it's important to see from both sides, not from not just from the German perspective. So this is there are 5 key areas of cooperation that may be in the future also relevant. Is the renewable energy and green technology, geo-risk and disaster resilience, education and research and development, blue economy, and marine sustainability, and last one is biodiversity, climate change, and conservation. So we talked about hydrogen earlier today. Yeah, I've managed to found this topic. Renewable energy and green technology in Indonesia is now. I think it's the the hydrogen topic is more become a hot topic. So I think there are some alliance between Germany and Indonesia. I think it was with PLN. And with GIZ also, the German-Indonesian Hydrogen Alliance, it's developing clean hydrogen projects. And the other is the Energy Transition Partnerships. We know that Germany is also a member of the JETP, the Just Energy Transition, and it helped Indonesia to reduce coal dependence. As we know that Germany is now a co-chair from JETP. So this is also a sign that Germany also committed to try to help Indonesia to reduce coal dependence and so on. So the third one is smart grid and battery storage. So this project is also aimed to modernize Indonesia's power systems, implementing grid modernization projects. And we also know we try to enhance the projects or to reduce fossil fuels dependence in Indonesia through solar and biomass energy in textile manufacturing. So we have also a case study in Indonesia between Siemens and PLN regarding smart grid solutions for energy efficiency. So this is another key areas, georisk and disaster resilience. BMBF had also funded one project and actually many projects in the field of earthquake and tsunami early warning systems. We know that in 2011 we had this Germany and Indonesian tsunami early warning system, and we had the tsunami risk in client 2 from last year. So I think I will. Landslide monitoring, yeah, okay. And there's ongoing studies that we try to also explore in AI-driven geospatial analysis to detect and mitigate flood risks. Here in Indonesia, there are some small projects in Solo, and yeah, we try to support this AI project also in Indonesia. Yeah. So yeah, we know that education also is a key pillar and also important pillar of our partnerships. We have here in Jakarta the EAD, the German Academic Exchange Service. The EAD exchange programs had already benefited from, there are over 30,000 Indonesian students have benefited from the EAD exchange programs. So the EAD had also had several scholarships programs, not just the exchange program, but also the joint PhD and also research grants. We try also to enhance this kind of research grants and also joint PhD, focusing on engineering, AI, and sustainability. And also the vocational training. We know that the German dual vocational training system is being adapted for Indonesian industries to enhance workforce skills. That was the former president Joko Widodo that had this idea. So yeah, and the last one I just put it there. I think it is also good that we can have this Indo-German Center for Sustainability in Indonesia, because I see that in many other countries there are several centers for sustainability, but I think in Indonesia there is no, nothing. Correct me if I'm wrong. Yeah. So The next one is blue economy and marine sustainability. We know that Indonesia had so many marine potential. So the Germany's roles is, in this case, is expertise in marine conservation, sustainable fisheries, and ocean monitoring technology. So BMBF had also funded one research project a long time ago, is SPICE, Science for Protection of Indonesian Coastal Ecosystems. We tried to renewed or remake this kind of research project. I hope this we can succeed to do that. This project is protecting mangroves, coral reefs, and also seagrass ecosystems. So in this area, I think a possible joint initiative is in the field of smart aquaculture. I had a talk earlier with someone from BRIN, I think, that also a great topic to do a project here in Indonesia, and also marine renewable energy and plastic waste reduction. Germany has tried to support Indonesia in plastic waste reduction. So yeah. The next one is biodiversity, climate change, and conservation. I never heard this research project before, I think, but this is a really successful BMBF research project that calls Indo-Biosis. This is Indonesian Biodiversity Discovery and Information System. So the collaboration on biodiversity mapping and conservation and strategies. So there is also some project in sustainable land use and forestry under the BMZ, the Ministry of Economic Development, research on reducing deforestation and also promoting agroforestry. In this area, our colleagues from the GIZ is also active. And the last one is IKI. I think yesterday someone mentioned about it, this International Climate Initiative under German Federal Ministry for Economic Affairs and Climate Action, or BMWK. So this IKI, International Climate Initiative, had also some projects in Indonesia regarding climate change and also sustainable. And this is really interesting because you can actually apply for some projects and get the fund from the IKI under the BMWK, under the German Federal Ministry for Economic Affairs and Climate Action. So yeah, so this is just some current initiatives and success stories. So we all know we had this Indonesia-Germany Energy Transition Dialogue, policy collaboration. We had also policy dialogue between BMBF and BRIN. So in this dialogue, we had already 4 policy dialogues with BRIN. We discussed topics such as a research permit for foreign researcher in Indonesia, mobility, research and funding programs, and also we have the next policy dialogue is next week. We have we will talk about open data management. So how the open data after the research ended. So about the share, open share and open data share. So yeah. So and from the DAAD programs, we also support some DAAD programs, scholarship, and also workshops. We try to always support the DAAD to make some workshops in Indonesia, not only in university but also in research institutes such as in BRIN, and also alumni meeting. I think it is also important to work here in Indonesia to get contact with alumni from German and Indonesia, that German students, and then and also to get in touch have an idea what can actually that we can make here in Indonesia, and also TFAT programs. So the last one is skills recognition and workforce mobility. ECONIT, or the what it calls actually ECONIT in English. No, I think it's Chamber of Commerce. Yeah, here in Indonesia there is one German chamber commerce in Indonesia. They have this pro recognition initiative, actually funded by BMBF. They try to support Indonesian professionals in Germany to get the certified, and also that their certification of from the university can also useful to work in Germany. So yeah, we talk about challenges and solutions. So I think it is also important to try to find the solutions, how to manage the difficulties and regulatory barriers, industry readiness. I mean, the awareness is also important, and also skill workforce gap. I think it's through training and also monitoring, and it's also it's important. So I think it's also important to expanding vocational education. I talked to Mr. Jayanata earlier today, and this is really promising. I think it is really a good project. So I think it is such a project that Indonesia needs to have a training program, to have this to expand and to strengthening their knowledge, and also to find also the partnerships with others, and yeah. So I think it's all. So the German embassy remains committed to supporting initiatives. We also try always encouraging industry, universities, and also policymakers, I mean the government, to collaborate. Unfortunately, there are some projects, some research projects ended this year, and that's why it's really important that I and you and the policymakers and the universities and also industry to discuss what we can also make, in not only for research but also for the industries. And yeah, I hope that such collaboration can enhance, can make renew, and new research project can be made in the future. So yeah, I think it's all. Yeah, thank you so much. I know this is really late. I think it is also good that we had 2 days for discussion and for getting new ideas. And thank you all, and thank you for having me for the last 2 days. And this is really good, and I find it really great that the research project, that the Enatex came this become. I heard the feedbacks. I heard all the positives results, and it's really grateful. I hope that that's not stop here, but continue more research projects and also collaboration. So thank you so much.
Yes, thank you very much, Mrs. Fitria, and I would like to keep you here on stage for the panel session. This was a very motivating and positive presentation to us, which programs and which activities currently are running under the German-Indonesian flags. let's say like that. And also a great thanks for the continuous support of the German embassy to our Enatex project. Thank you very much. Okay, then I would like to open the panel session now for the rollout and perpetuation of our results, pretty much on the academic level. Therefore, I would like to invite representatives on the one hand from our universities, but on the other hand also from the industrial part. And I would like to back on stage from the University, Applied University of Niederrhein, Professor Dr. Monika Eigenstetter, please. From Atmajaya, please on stage Juliana Munyati. From STT Bandung, I would like to back on stage Mr. Mohamed Widodo. Then from the BMBF, our funding donor and DLR, Mr. Roland Keil. From ITSIS project lead, please, Mr. Bernhard Wern. And we have also a special guest. A special guest is Mr. Michael Sang from APSIFI, the Association of the Producers of Synthetic Fibers. Please on stage. Thank you very much. Bernhard, ich setze mich ganz. Oh ja, warte. Okay, thank you for joining us to the last panel session here, to the last stage of our 2 days conference. I think now we have the time and also the possibility to talk all together about our current situations, about our efforts, our results, and about the rollout of our results from different perspectives. Therefore, we have here a combination of different representatives of different stakeholder groups, if you want to say like that. And each of you is very, very important to contribute and to roll out our results of Enatex into the society. Therefore, I would like also eventually to start the discussion, the interview discussion with the university representatives. And because you were our main actors also in our research project, and not only in that research project, because according to your already existing cooperation between the German and Indonesian university research collaboration, that project could actually also happen and was initiated. Thank you very much for that to the beginning. And I would like to start with eventually also with an interesting transfer questions to Atmajaya University, to Moni. And we are talking pretty much about changing the textile sector towards more sustainability. But we also talked about changing human behavior to allow this system change. And if we would take a closer look also to maybe a specific part of our society, means also to the university itself, therefore I would like to become the allowance to raise the question that with what concrete steps at Atmajaya have been taken to integrate the results of the Enatex project into your research and teachings. And for example, you could, if you're able, share some examples of how these insights are being applied in universities or in the scholarly work. That would be very interesting. What has happened already?
Yeah, thank you for the question. So, Atmajaya have a Center for Sustainability and arranged by Faculty of Economics. But at my faculty, so at the psychology department, we have a subject psychology for sustainability, and I teach the subject. So that's a very interesting. Earlier, my students had no idea about sustainability and this topic, but at the end, raising the awareness, and also they design some action program and implement it to the small scale. Really interesting. And I think so in the wide spectrum for our next cooperation. So we are developing a subject on sustainability and so supported by DAAD, and we have to implement it in our university, and also STTT implemented either as a certification program or as a part of our master program as a Swerpong, so something some courses and also a certification program. It's very clear. Atmajaya have two compulsory subject, 4 subjects from the government. So it's also possible in the Indonesian scale. We develop or offer subject sustainability, but at Atmajaya we have a compulsory subject in so-called multiculturality. So it's possible for Atmajaya and also for Indonesian university higher education to offer this kind of subject.
Yeah, thank you very much. I think also just to add on, if you're not currently have at university the capacity to build on a direct new study program, because it's something for midterm or long-term activities, but to find here the holes to integrate it into your current running curriculum. And as you said, you have some compulsory modules you have to do, but eventually also from the definition onwards, you can see where is it fitting that you're integrating the results into the running curricula. Thank you very much. And I would like to pass the microphone then, of course, to Mr. Muhammad Widodo. And it would be very interesting to hear about, so at STTT Bandung, in the textile scholar programs, university programs, how have you already implemented these sort of sustainability insights into the running system, and what is currently planned?
Yes, thank you, Katja, for the question. I have to tell you that the idea of sustainability is not recent for STTT, because we have started with the, I think in 2015 that we started within the curriculum by having a course called the Biotechnology for Textile. So the idea with the biotechnology of textiles is to consider like the environment and also the sustainability in the chemical process. At that time, we had an idea to go further with the using of enzymes within our textile finishing technology. So that's the start of having the having the idea of sustainability. But of course, at the time, we didn't have that term in official way, but we have the idea that this is the entrance for us to get into the sustainability. And then from then on, we have other ideas of working with sustainability with the course that we call the Sustainable Textiles and Clothing. So in 2018, when we established our master program, we have one special course called the Sustainable Textiles and Clothing. It's not very deep, but it's kind of an introduction for our students to go further in the direction to the sustainability. So this project is kind of a validation and also put the motivation for us to that this is the right direction. So this validation and also motivation for us to go further with the conviction that this is the right direction that we are taking. So from this point on, and with all this experience and also with the the findings that we have from this project, we'll put that in research areas also, because then we have some ideas of how to do this in sustainability, and also we'll put some of the findings or initiatives in the course, in the curriculum. And then it is also one of the things that we will go further with the cooperation or collaboration with the industry. That's what we have in mind for now with this project.
And I think it's also a big potential, USSTTT, which is under the Ministry of Industry and directly connected with the industrial sector, with the companies also in Indonesia, that there is can be a huge outreach also towards these cooperation between university and industries in that way.
Yes, that's true. Last year, I have an honor to be the technical source for the circular economy for textiles. That we prepare the roadmap for circular economy, and then we also have some projects with the Ministry of Environment and Forestry to work with the POPs, the persistent organic pollutants, which deals very much with the sustainability in terms of the textile processing. Yeah.
Thank you very much for these first insights. Thank you. And then I would, of course, like to pass the mic to the German university representative, to Monika, from Applied University of Niederrhein. And you took also together with Atmajaya the head of the social science research in that project. And according to the history, the development of the science in Germany, but also international. So in the past, it was quite often more the topic, the focus was laid on technology research on that way. And nowadays, social research, you find it more and more also in, for example, open applications to apply for funds. And therefore, I would like really to raise that question to you as an expert in that. Why do you think it is valuable to include social science in this rather more technology-driven sustainability area, also in research?
I think it's not only sustainability, but it's technology in general. When we are, for example, thinking about that digitalization is now driving sustainability, and sustainability is driving a digitalization, and we are, for example, in the future also integrating artificial intelligence, then you have always this intersection with the people who need to deal with that. And then we have to integrate also explainable AI and all these things. And in the German Association of Psychology, DGPS, so there was a founding last year of the first section of engineering psychology because of all these intersections. So we have been part of the industrial psychology, but now we have a special deepening in engineering psychology that the people are able to deal with the complexity of all these issues in these socio-technical systems. So my experience, I was always working as a psychologist with engineers. And so the engineers always came to me and said, hey, I made the wonderful machine or the wonderful process, and now please teach the people and adapt them to the process. And I say, no, that's wrong. You have first to start with the people and to understand how they think about their cognitive ergonomics, and then you can adjust the processes and the machines in a way that they are intuitive. If every machine in this world would be like a smartphone, we would have less problems, yeah, because we can easily use a smartphone without having to read a long instruction. But think about which kind of machinery is sold from everywhere, and it's not running, yeah. And what I have learned in this project, and therefore I think it's really important. I did not know anything about dyeing and finishing, and I learned a lot. And what I learned is if you just pull one factor, maybe the dyes, the temperature, the additives, the water, and whatever is all combined, it changes the whole system, and therefore it's so hard to change it because there are so many factors contributing, and you have to understand the system. And we have first to be able to describe the system. And so we need much more analytical tools, and we have a lot of analytical tools, maybe out of the high reliability organizations. For example, aviation, they used all these technologies very long time, and we have to now to transform that
into sustainability, because sustainability or technology in sustainability is as complex as aviation. Or think about chemical industry itself, it's also using these tools. And now we have to bring that to the bottom line, that everyone can use that. It was an expert knowledge, and now we have to roll out that. And therefore, the social sciences are really important in the intersection with engineering.
Okay, thank you very much for this approach under the social sciences. I think also what I learned, for example, out of that project is that the integration of social sciences has multiple approaches, which are all proven for their validity and which are very necessary to drive that formation in that way. And also new streams are coming maybe from year to year inside, as you know.
Yeah, the funny thing is that psychologists sometimes are experts in methodology. They do not know anything about engineering. They have to learn all the time, but they know about the scientific methods and how to apply them, and they know how the people are functioning and how you have to transform expert knowledge to the knowledge to the people.
Okay. Very helpful. Thank you very much, Ms. Eigenstädter. And yes, now we talked about with the universities at this stage, so how the rollout could be. But we would also like to talk to one person who is representing also, let's say, a roof association of the companies, because just working with universities will not change the textile sector alone. Therefore, welcome, Mr. Sang. You are representing today the Association of the Producers of the Synthetic Fibers here in Indonesia. Thank you very much for joining us. And as Association for the Synthetic Fiber Production Operators, Producers, I would like to know, maybe you can give us some insights on the one hand about your role currently in terms of promoting sustainability in this sector, in the textile sector, and eventually some insights about your current interconnections also with the research area. Mm-hmm. Eventually, if there are some, maybe not yet. Yeah. But first of all, your role as the association and in terms of sustainability. Thank you.
Okay, thank you. So again, I represent the UPSIFI, which is we call it the synthetic fiber producers in Indonesia. And honestly speaking, the upstream market of Indonesia is facing a big challenge of surviving at the moment. And of course, we do work with a lot of institutions, for example, the Industry Ministry, the Energy Ministry, and of course with a few institutions as well, like STT, to really figure out how we can implement small things that we can do to improve our efficiency and in terms of production efficiency and energy efficiency. Because as an example, in my company, as one of the members of the association, is that we try to aim to improve our R&D, and we do actually share those findings with our peers as well on how we can do on energy efficiency, process innovations, and whatnot to be able to compete with importers or even external factors, external competition from China, Turkey, and India, and whatnot. So an example that we do, of course, we try to aim to share, again, for example, like through my company and our association, we share with other peers, other fellow companies as well, on what we can do. Small steps. It doesn't have to be very major, significant investments. Like what we like to share, for example, is small investments with big returns. Like one of the things that we did in our company was that we actually saw, like for example, the compressors. What a lot of people don't realize is that you can save so much through your compressed air just by switching and realizing how much pressure you need. A lot of the compressors that's going on in the yarn factories, especially right now, they're being set at the manufacturer's setting, which is a 7 pressure bar or 8 pressure bar, whereas the requirement that's needed is probably only 2 to 3. So the gap of 4 pressure bars is equivalent to at least 25% to 30% cost differential just from the air. And we did tell them that, you know, you don't have to invest in all these new technology. All you have to do is just set your pressure down, output compressor pressure down from 7 to 5. And if you buy a new compressor that has a low pressure compressor, that can generate much more air with much lower electricity. These kind of investments is not significant, but it does have a lot of impact, not just to your costs, but to the emissions output as well. So that's something that's just one of the examples that we do, and there's so much more that we do internally, because my company does both yarn and fabric, so we're quite an integrated company. And we do work very closely as well with STT on how we can improve further on our R&D and to see what else we can do individually as a company and also as an association to grow together for the textile industry in Indonesia.
Yeah, thank you very much also for this very interesting example. That means also that was also one of the Enatech's findings. So we called it the low-hanging fruits. So with less investments, you can achieve already, I think, 25% or something like that of energy savings in a company. And of course, if we are following a sort of a hierarchy, that is the first thing to do then. And the important aspect is, as you also said, it's important that the company operators know about that, and so that we disseminate that also into these members of the associations. I think it's a very good aspect. And yeah, thank you so much, pretty much. And I hope also with that project that you all will intensify your even lively connections with research and companies, and especially in the aspect of the sustainability activities. And thank you very much. Then I would like also to shift also now to Mr. Kai from BMBF DLR. And yes, the thing is like that. Every good thing comes to an end in general, and so is also with our project. All projects are defined with a project start and a project end. Otherwise, it would not be a project. So, and this is currently also the issue with Enatech. But in order to have the best possible rollout of our activities, maybe we can learn from your experiences as the funding donor in that role. What do you think? Which recommendation could you give us? Which are the most effective strategies in ensuring that the project results continue to generate long-term benefits beyond also the funding cycle? Maybe you learn from other projects good examples and can translate that to us, how to go on.
Thank you very much for this question. And I'd like to emphasize that it's a key question you ask. It's the question, I would say. It's the question about impact of a project and the best possibility to obtain this impact. And to be honest, this question should not only be asked now, but has been asked before the starting of the project. And that's all about the thoughts and the concepts you already heard a little bit from me in my talk, the frame of our funding philosophy. We are thinking about what's the best ground to prepare to achieve the best impact after the project. We don't only want to fund the project for 3 years' sake. It's not too much. That's not enough. Yes, and so we have to look first at the design of the project. How can the project be designed to reach out afterwards? It's about the consortium. It's about the work plan, and it's about already the aim of the project. What are the what do you really aim at? Is it only not only, but could it be only technological aspects or also other things, psychological, socio-ecological, transdisciplinary things? And I think the project has very well addressed all these challenges that have to be thought about before the project starts already. You have the joint cooperation between industry and science. This is very crucial to be successful after the project. This is one point I can recommend also now. Continue the cooperation with the industry towards the scientists. And yes, the other thing is that you, yes, also integrate in the project already not only the research but also the capacity building aspects, the trainings, and the integration into curricula. All these things are very essential to really yes, have a positive effect on long-term scale. Let's, I think, to put it in a nutshell, the crucial question, how to be most successful. And I think what I've learned in these 2 days, you have built a very good base of trust, of cooperation in these years. You can build upon, and you can build upon by several activities of transfer. And I hope that you will also find new ways of support. Ms. Fitria already mentioned in her talk, for instance, the big initiative IKI in Germany. It's similar to Klein, but on a more applied and a bigger level. May you be successful in applying for this to have a rollout to a lot more of companies in Indonesia or in other South Asian countries. This could be a possibility, for instance.
Thank you very much, Mr. Kyle. I think also from the beginning on, that's a quite important question to ask also in your proposal application forms. So we had to state in the beginning on, so the rollout of our activities, and we knew it already, but now we feel it also by heart that this is so important, because when you're really working very close for 4 years together, everything what has been built up and so on must be secured, guaranteed to hold on in that way. Therefore, we are very proud also to have this lively network, not only between industry and universities and research entities, but also the support of these agencies, associations, supporting associations, and also from the government part, as for example also from the German embassy here in Indonesia. And this was from the beginning until today, and we know also that you're providing sort of cooperation formats also under the embassy, for example, when we are currently not here in Indonesia, eventually the next month, that you're going ahead with workshops, with policy dialogues and so on. And I think our members now eventually might be also in your mind, eventually to become invited and to continue also in other formats. And therefore, one of my questions goes also to Mrs. Fitria now in that way. And this is, you was talking about the formats that the German embassy in Indonesia can provide to encourage cooperation. But now that you know a little bit and feel a little bit our project, what do you think within the next this year or next year, eventually, which sort of formats eventually could fit to us, where we find again a place to meet? It's maybe a little bit hard, but eventually there is something interesting what also would help us a little bit.
Okay, thank you for the question. I mean, I think for last 2 days, really, I think I have really so much in mind, and I have really so much ideas. I think I will start with a dialogue between researcher. I mean, this from Anatex, this is really experts, and we have such as we have in our division, in our section, science and technology section, we have actually since 2019, I think, it's called HESTI. This is Higher Education, Science and Technology Innovation. It's a group consists of researchers from all the fields, and it's not only from Indonesia but also from Germany. So I try to always to have this regularly meeting yearly, but sometimes it's not it's not happen that I expect. But this year I will try to revive these meetings, and it will be great if I can invite some researcher and also experts from Enatech's projects that we can also sharing. It's really informal, and it's sometimes offline but also online, so we can I mean, you can stay where you are and then just click the WebEx or Zoom link, and then we can talk about everything, about science, about ideas, what we like to make together, and then I think this is an important part. So yeah, this is one of my ideas in the next month maybe. So yeah, and other of that, and I already said we try to have this regularly policy dialogue with government, and also dialogue with the alumni, and also with other research institutes. I also try to always to contact and to ask if there's any projects are ongoing. But because sometimes it's not so, it's different from other countries. Example from French, they if some projects in Indonesia, they have to tell the embassy that that's ongoing projects in Indonesia that between French and Indonesia. But in Germany, it's a little bit different. So yeah, we'll be actively ask all researchers that I met, and yeah, try to facilitating contacts if needed. So yeah, and yeah, sharing networks, it's always important. Yeah.
Thank you very much, Ms. Fitria. And for us, just vice versa, it's very important to have this rollout that we are visible now. And that's very good for us to feel into here. Thank you very much. Okay, then I would pass the last question to the project lead, Mr. Bernhard Wern of the Enatech project from ICES, from Germany, for a research institute. And I would like to ask you, with the perspective of the project lead, so which lessons learned you took, and what could you recommend to all of us for the rollout of our research eventually?
Yes, thank you very much. Which lessons learned? Quite a lot of lessons, but one thing came up now. It's an emerging sadness that the project is a little bit over. And I have the feeling that quite a lot of people want to go further. And that is really a good experience in this project. And that's one thing what I have learned, that if you can reach a trustful cooperation, then it would be easy to work further. And you need, perhaps you can then work for 10 years or something, and you will make really a difference. So perhaps this project is only a starting point, and with this EKI you mentioned, it can be. But if you make an international climate initiative, then we need all of your help. Then, for example, we would need the help of your association, because it's really, really competitive, and you have to state that you know the whole Indonesia, every single woman and man. So it would be really crucial that you help with letter of intent and things like that. And also we need, of course, the Indonesian ministries, if you make international climate initiative, and then you would be, I think, the right person to address, because then we need really letters of ministers of the highest level. And then we need the two universities, but also perhaps others, perhaps also PRIN and so on. We need then of really high level good contacts and good cooperations, and then perhaps we have a chance. Yeah, and that would be really lovely if we could try to set up a project like that.
Good. Thank you very much. And to that point, I would like to open also some questions from the auditorium. Is there any current questions you would like to pose to the panelists? Good, so far. Then I think, yes, we managed a very successful 2 days conference. And thank you very much to the panelists here to speak with your expertise to us. Thank you very much. And for the closing remarks, I would like to pass the microphone to the project lead, Mr. Bernhard Van.
So the last words are not easy always. As I said, that is a little bit of, yeah, I don't know what, a certain feeling that is the last big conference we have. We had 3 of them here, 2 in Jakarta, 1 in Bandung, which was also really successful with quite a lot of companies also. And so I have the feeling that this project can make a difference. And I was always a little bit suspicious to go further, but perhaps we try it with Iki. Yeah, we could try it. And my only thing I want to say is thank you all which are still here. Thank you all of the colleagues from all the different partners. And it was really a pleasure to work with you. And I'd like to work with you further. And now I think we go to the dinner again, if I have it really in mind, yeah. And then I think we go to the unofficial part.
Thank you to all speakers and to all the hosts. You may be seated now. Oh, okay. We'll take some pictures first before we see that again.
Bisa kasih plakat buat Michael, Pak Michael.
Okay, once again, thank you for all hosts and host speakers. And now I would like to ask kindly Mr. Bernhard to give a token of appreciation to Bapak Michael. Before we conclude today's session, I would like to have some announcements. I will talk to some announcements in Indonesian. Untuk bapak-bapak yang ataupun ibu-ibu yang membutuhkan materi ataupun sertifikat bisa mengakses pada link berikut yang ada tertera di dalam layar. Ya, seperti ini. Konten yang akan diberikan akan diperbaharui secara berkala ya. Terima kasih. Ladies and gentlemen, thank you for all yours today. To all speakers, panelists, participants, thank you for being with us for the last day of International Conference on the German-Indonesian Annotex project. We hope you see you again soon. Safe trip. May God bless you all. Goodbye. Sus.